Hello, and we're live again. Right, what's this one about today? No doubt you're telling the title. It's the flat Earth again. Right, last week I was contacted by James from Modern Day Debate and asked me if I wanted to do another flat Earth debate. And I thought, how have I got myself into this? But anyway, I couldn't say no, so I agreed to do the debate. It was supposed to be a tag team. There was supposed to be me and Dapper Dino against two flat earthers. And then when it got closer to the date, I got another email off him. It's now going to be a three-way tag team. And it's going to be me, Dapper Dino, and Leo Phileas. So I thought, I've seen them two. They're one of the most educated people you could be on the same team of. So I thought, this is going to be dead easy for me, especially with them two on it. So in this one, I don't actually do a great deal because when they started getting into the science bit, it was just... It was beyond me. It really was. So I just enjoyed being able to take part in this debate and basically just sit back and just observe. It was brilliant. To me, it's probably one of the best flat Earth debates I've seen, actually, because the flat Earthers did actually put up some arguments. They weren't just the normal, like your Nathan Thompsons, and it wasn't like that. So yeah, to me it went quite well, but for me it was dead easy. I just had to sit there and try not to laugh. It was hilarious. It really was. If you don't want to, I know a Junk Shop's in, and I think you might have watched some of it on Friday. But if you don't want to go through the full 2.5-3 hours or whatever it is of this debate, I would advise you to watch the opening statements, especially when it comes to Leo's statement. He had me in stitches. I had to mute myself because I thought I'm going to just burst out laughing. I think you can actually see me get a bit of a smile on my face with what he was saying. It was brilliant. It's one of the best opening statements for Flat Earth I've seen. It was absolutely hilarious. Anyway, I'll just say hello to whoever's just jumped in that and see that Junk Shop's here. Hi, you've got your coffee. You're probably better off with tea, mate. Mark Caesar, hiya, Mark. It's good to see you. Tobin, it's good to see you as well, mate. And just a quick update. I think I'm now at about 109 subscribers. I gained a few more subscribers from Friday, which was a bit baffling because, like I say, I didn't actually do a lot. The last time I did the debate, I think it was about 6-7 minutes opening statement I did it on navigation because that's mainly my bit. This time I thought, I'm just going to keep it short, so I just kept it short, and so I was the first one from the Globe Earthers to do my opening statement, and I was literally a minute, and then it was Dapper Dino. He did a really good one, and then Leo had me in stitches. So I hope you all enjoy it. I'll still be hanging about. I've just come in from outside. Sun's shining through the window again. I've just been replacing some fence posts, so I'm about knackered because I've been digging all afternoon, replacing some fence posts. But anyway, I hope you enjoy it. It was a good laugh. I absolutely loved it. Paul loves seeing a new argument. Yeah, the Starfish Map. Yeah, I'll just mention that. Yeah, because I went into that last time. I've got it here. Basically, what the argument is if you look at a globe, I've still got it here from Friday. If you look at a globe, you've got all the longitudinal and latitudinal lines on here, and from the equator, they get narrower and narrower as they go up, and this is all the way along the globe. And obviously, going south, they're at the widest at the equator, and they go narrower as they go south. Well, if you take any navigational map, not like an orienteering map, but a navigational map, you can see they've got the lines on it. If you look at them, they slightly go up. This is only a small area, so you can't really see it that well. But the lines get narrower as you go up. If you take a larger map, like this one here, I don't know, you won't be able to see it that well, but the longitudinal lines from the bottom to the top, they get slightly narrower. Now, this is only about 1,000 miles, so they do get narrower. And I don't know if I've got one. I think I've got one somewhere. Where's me Australia? I did have one of Australia. I've got some really old maps here. I don't know if you'd be interested in seeing these. These are dated 1912, I think. And that's like the south of England. But all these maps have got the longitudinal lines on them. Now, if you take a look at the maps and then look at the globe, now this has all got the degrees and everything on the globe. And if you take a look at them, match them up with these, they match up absolutely perfect. They absolutely match up to whatever's on here. You get the Australian map, go to Australia, and Australia goes east, and it starts at roughly 115 degrees east to 100 and just short of 155 east. So if you can see there, I don't know if I can see where the map is. There. So if you look at the longitudinal lines, they all marry up. You take a look at the map and they all marry up. And what my argument is, if you take all these maps, these navigational charts, I won't open this one up because it's massive, but if you take all these navigational charts and lay them all down so that all the longitudinal lines all match up, it works perfectly fine in the northern hemisphere because, like I said, from the north going down to the equator, they get wider. So I'll just fold that in. I don't know if you'll be able to see it. Say if, yeah, you can see that. So say this here is the northern hemisphere. So the longitudinal lines from the North Pole get wider as they get to the equator. But like I've already said, when you get to the equator, they get narrower again, which is like that. So if you were to marry all the maps up, joining all the longitudinal lines together, you'll get away with it till you get to the equator. Once you get away from, you start going south of the equator, to get them to marry up, that's the only way to do it. Or you're going to end up with like an half moon shape at the bottom or wherever you're going to take it. But that's the only shape I could make by marrying all the longitudinal lines up. Well, that makes a star. But after I've drawn it, I looked at it and thought, yeah, but if you fold all these in, obviously it's with paper, but if you could get them all to fold in so that them lines then are all joining back up again, what's it going to give you? It's going to give you a globe, proving that if the navigational charts work and you can successfully navigate with these charts, proving that it's accurate to the Earth that we live on, and these all marry up with what the globe is, we've got to live on a globe. You cannot make them fit on a flat Earth. It's impossible unless we live on a star-shaped. So that was basically my argument on that, on the first one. But I couldn't be, to be honest, they'd only contacted me on the Wednesday, and I couldn't be bothered to do any more research onto it. So I just thought I'm just going to do a very short opening statement and then just leave it to Dapper Dino and Leo Phileas, and it was classic. But anyway, I won't waffle anymore. I will start sharing it. Like I say, don't have to watch all of it, but I would suggest waiting until Leo does his opening statement, because to me it was hilarious. I'll still be hanging about in the chat. I'm going to go downstairs for me tea, because the wife's just made tea. But I will be on my phone in the chat, so if anyone wants to say anything, I should be able to pick it up. Come on, Paul, you know Australia is upside down and doesn't exist anywhere. Yeah, some of them do actually say that, don't they, that Australia doesn't exist. That's crazy. And I'm not too sure whether all these flat earthers believe it. I really are. I'm just not convinced that they all believe it. I don't know whether they're just, well, even Leo says that. But anyway, I won't waffle on anymore. I'll start sharing it, and hopefully you'll enjoy it. So let me just see what I'm doing here. And right, yeah, I just need to mute myself first, don't I? Because if I don't mute myself, it'll go back through. Unmute myself. What am I like? Right, hang on, let me move that. What am I like? Unmute myself. What am I like? Oh, I'm echoing now. Right. Right, so if I... Right, I've been that. Right, I'm back again. I took myself off. Right, just bear with me. I know what I've done. When I put shared screen, I've just got to re-find it. Bear with me. Right, share screen. Share screen. Share audio. Right, this should work this time.
Hey everybody, tonight we're debating flat Earth versus globe Earth, and we are starting right now with our flat Earth team's opening statement. Gentlemen, the floor is all yours.
Right, I'll jump out.
Thank you very much. Pleasure to be here. I'm Bev, try thinking. I'd say I'm not necessarily a flat earther because I'm a geometrically accurate realist, and flat is a two-dimensional surface, and we know from reality that elevations are measured from a horizontal base on a vertical datum. I'm here mainly because troll-induced has brought me into this arena from just stating reality facts. And so, I mean, that's why we're here. Forced to try and prove to myself that level is horizontal, and stating that the drop of the horizon is a geometric fact. So having to prove that level is horizontal, we ended up going back to first principles, right back to the basics and the basic understanding of where we're at. We found out that it's a logical base, logic and geometry are what put me here in the first place. And so, yeah, basically it's a proof, a geometric proof in reality, using 3D Euclidean space to prove that level is horizontal, which a lot of people get freaked out about, but most people know it as a reality. So we've devised a test. I'm not going to go into the test today, but I mean, anybody's willing to come round and view it if they want to. But the principles, the basic principles are this. I'll give this on the board. We've got a water level. There is a water level here, but this is a depiction of it. So in reality, you've got your water and it levels out. This is called a horizontal. One of the globe models is the hump and the drop. You've got two different models. You have to decide if you have a globe model in your head. You've got the constant drop from the point you're at, which we call the nutsack drop, we call that. And then we've got this one, which is the hump, the raise in the center, from one side to the other. That's basically where we're going to be going, or where I'll be going. Just basic logic and the contradictions within this. I personally just deal with the reality model and what is. So I'll be staying firmly grounded in mathematics and geometry and logic. So thank you very much. I'll pass it over. Who's next?
Yeah, I can go. You hear me good? Really good. So yeah, basically, I'm right the hand, Chris. I've been in the debate for a while, and yeah, I'm not here to debate either, right? Like I did that. I know you guys might be new to the debate, and you might have been expecting, oh, gravity this, gravity that, you know, oh, this and that. But what if you're true to finding out the truth and getting down to what is real, you know, which one or neither? Because I don't consider myself a flat earther, right? Like flat and ball is like Democrat or Republican, right? I'm like, I'm not the politics, right? I'm not it, and that's how I see it. It's a political realm of people that are like, I'm this, you're that, I'm right because I'm a this, and you're wrong because you're a that. And you know, I was okay with that when, you know, because of course you argue from your side and you're like, oh, these are the facts that I have, and they'll be like, oh, these are the facts I have. So now it's just like, how do we both agree? Like, what is going to determine whether what shape anything is, right? Like if I have a grapefruit, right? Now, how do we know this is not a square? Well, geometrically, right? Geometrically, there's aspects physically, there's physical aspects to round objects, right? Now, again, I'm with Bev on the horizontal. Like if you got the glass of water, right? Look at the line of the water would let you know that this object is not straight. So there you go. And that we start working from there. You start working from things that are demonstratable, and then those demonstratable things, like how this water is in that line, right? We can't quite describe it with words perfectly, but that's where geometry and geometric values come in, right? Like if you have a circle, 3.141, you have the diameter will go around a certain amount of times always. That's how it works in the real world. And we just switch that real world working into a language that we can talk back and forth with and prove stuff with, right? Like if I wanted to know if this was going to roll down a hill, like because round objects will roll down a hill, right? And you can prove how the behavioral aspects of the hill is off the horizontal, right? So water will tell you if you have a horizontal. So they're just logical proofs that are based on the reality. So if your logic is not based on reality, you don't have logic. So I'll concede the rest of my time. And yeah, thanks for having us, James.
Flat Earth Rossi, the floor is all yours. Final speaker for the Flat Earth Sides opening.
Right, yeah, thanks, James. Hope you can hear me fine. Obviously, my camera's not working. Is that correct? Okay, no dramas. It's good to be here again, and I've been pretty busy, but obviously I've been a strong Flat Earth supporter for quite some time now, and the one thing that most people are always hammering on about is to show us a Flat Earth model. And this is always a huge problem for Flat Earthers because basically the model only works at full scale. And, you know, the globalists are so used to seeing tiny little models like the things you hang above your baby's crib that they can't sort of understand reality any other way. So it happens at true scale. And I think the best comparison that I can give to help people to understand how the nature of the model works is to think about a fish underneath the layer of a frozen lake. So the fish under the water, under the ice, when he looks up and sees a hotspot apparition of the sun on the ice, for him, for all intents and purposes, that's his source of light and warmth, and it sort of sends out this glowing light underwater, and it's our equivalent of daylight, for example. But then we got another fish, say a few hundred meters away. When he looks up through the ice to see the sun, he sees a completely different hotspot apparition of the sun on a completely different part of the ice. And if it's a huge lake, or you've got hundreds of different fish all looking up at hundreds of different variations of different parts of the ice, seeing their own version of a hotspot of the sun. So now if we expand that to the flat Earth model, where we have the equivalent of a layer of ice, the firmament, some estimates say at least a good 70 miles above the surface of the Earth. So every time we look up through it towards the actual sun, now the actual sun might be 100, might be 1,000, could be 50,000. We don't know how high the real true sun actually is. But however high it is, as we look up through this lens of the firmament, that is where we will see our personal hotspot apparition of the sun. So a person 1,000 miles away, looking up through the firmament to the sun, sees a completely different hotspot apparition of the sun in a completely different spot. And yet everybody believes that that is the one and only true and actual sun. So that is where we have this huge problem, where people of science try to measure things and try to say, well, if we triangulate it, well, we calculate it's 93 million miles away, which is completely inaccurate. Everything is where it actually appears to be. So we send up hot air or helium balloons with cameras attached to them. We can get up to about 130,000 feet is about the maximum we can get to. And that gives us a lot of information. That works out to be about 23 miles off the top of my head. The sun never appears to be all that much higher. So if it is 70 miles, well, that's a bit of an overestimate. Might only be 50 miles for all we know. Might only be 40. Might only be 30. But, distance is very relative when it comes to, you got nothing to focus upon or to compare it to. There's nothing else visual to be able to take an estimate from. So we just take a rough estimate and we look at what we can see. So the sun is not much higher than our 23-mile range. The Earth down below, the horizon is always at eye level, of course. We see a thin blue layer, which is, for all intents and purposes, our blue sky. So when we're on the ground looking up through the blue light, that is all we see. We think we're just, we think we're looking into infinity, but really we're not. We're only looking up about 10 to 15 miles maximum. That's where the blue sky limit is. And then, of course, the sun itself is merely an apparition much higher. And in between that is a huge black zone. So we have a lot to understand or to comprehend about the nature of light itself. It's not what we think it is. It is actually that blue layer is electrostimulated by the sun and causes it to glow, much like an open-air neon light bulb. And that is what gives us daylight. And it works the same even if you believe in a globe, because otherwise, in the globe model, you've got the sun 93 million miles away, but it's streaming sunlight throughout the entire universe, obviously, and yet we still get night. So how can we have night if there's only a tiny shadow of the Earth blocking all this sunlight? So obviously, light itself doesn't exist even until it actually stimulates something or reflects off of it. And our atmosphere is what gives us daylight, which is not exactly sunlight. Sunlight will give a distinct true shadow, whereas daylight just gives a gentle, warm glow. It'll light up an entire room without any direct sunlight entering it. So once we comprehend our personal view of the sun is unique to us, so there's like 8 billion different suns at any given moment, depending on the time of day, I guess. And the nature of light is also unique to each and every viewer, like crepuscular rays, for example. No two people will see the same two crepuscular rays. So I think I'm sort of trying to get ahead of myself a bit here, but if we go back to the analogy of the fish, looking up at the personal hotspot of the apparition of the sun on the ice, that is virtually how we are looking at the sun, which isn't actually the sun. The true sun is well above that. And so in the flat Earth model, as the sun goes around us, a huge circumference of about 25,000 miles, which is the same as the equator, it actually gets higher to create the seasons. As it gets higher, it appears to go in a smaller circle simply because it's further away, and that will give summer in the northern hemisphere simply because the direct sunlight through the firmament is what creates the most direct light, and most direct light causes the most heat. And then as the sun gets nearer to us, it appears to make a bigger circle, hence it appears to go south or outwards. And that's why we get summer on the outside, on the south side. And the diluted light coming in at an angle then isn't as strong. So therefore the inner side gets the winter. So that's our basic model with the seasons and sunlight explained. And I'll leave it at that.
Thank you very much. So those were the openings from our Flat Earth team. And folks, we will kick it up to the top row, which is our Globe Earth team. And want to let you know, folks, we are thrilled you are here. Modern Day Debate is a neutral platform hosting debates on science, religion, and politics. And we're fully neutral. So we only host debates at this channel. So hit that subscribe button and that notification bell as well for a lot more juicy debates coming up in the future. And so with that, Globe team, thanks so much for being here as well. The floor is all yours.
Thanks, James. Right, tonight I'm not going to bore you all like I did last time with a 10-minute PowerPoint on navigation. My opening is going to be very simple. The evidence points that the Earth is a globe. Navigation, satellites, GPS, shipping, airlines, detections of earthquakes, locations, the moon phases, and so on. My main one is navigation, without going through the PowerPoint. That is the globe. On the globe, we've got longitude lines and latitude lines. When we take a navigation chart and compare the navigation chart with the globe, the lines on this all match up to this. Therefore, this is a two-dimensional representation of this, and it works. If you were to put all the navigational charts out flat, you would get that shape. And when you fold all these corners back in, it gives you a globe, proving that this is a globe. Or we live on a star-shaped flat Earth. And that's basically my opening. Just a short one this time.
All right, well, I guess that means I am up. For those of you who don't know me, I'm Dapper Dino. I have a channel. Feel free to hop on by. And I, of course, am coming to you from the actual flat Earth, the one that is, in fact, centered on Antarctica. Because one of the curious things about the flat Earth model is that it fails increasingly as you go farther and farther away from the alleged center, being the North Pole. And so it's very curious to me that we have Southern Hemisphere flat Earthers who don't have this model, but who stick with the Northern Hemisphere centered model, which actually doesn't work at all. Because one of the earliest reasons that humans thought and eventually knew that the Earth was round is actually because of navigation, as Paul was saying, but not modern navigation necessarily, even very ancient navigation. Early sailors used things like theodolites to measure the angle between where they were, or wherever the stars were on the horizon, and things like the northern pole star Polaris, or the equator, not the equator, sorry, the ecliptic of the celestial sphere. But also when you get to the southern hemisphere, there's also the southern celestial pole, which rotates in the opposite direction, if you're looking at it, to the northern celestial pole. None of this actually geometrically works out in terms of angles if you're on a flat plane. You have to be on something that curves as you move over it to any significant difference. Now, the flat Earth model itself fails to account for anything with any actual predictability. The best that we get are these post hoc explanations that don't actually allow us to predict anything, especially not better than the globe Earth model. One of the most important things that science lets us do is find out what we should expect to happen in the future based on our scientific understanding. So for instance, in chemistry, if you have a good understanding of chemistry, you'll know not to mix chemicals A and B because there will be an explosion. Or you will know that if you undergo process C with these petroleum products, you'll get nylon, a very handy artificial fabric out the other end. Flat Earth has yet to be able to do this. No flat earther is out there telling me exactly when the next solar eclipse is going to be and where and why. Flat Earth can't even tell me where the planets are going to be if I look up in the sky. But the globe Earth model with the heliocentric solar system has been doing this with extreme precision for hundreds of years, and the globe Earth model with a modified geocentric was doing it with less precision, but still very high precision for thousands of years. The only way that the flat Earth can work to make predictions about what is going to happen in the heavens is if you assume that the whole firmament, if you will, itself actually rotates and part of it goes under the ground and comes back up, which is why all the ancient civilizations that believed in the flat Earth actually believed that the sun came up out of some part of the Earth, went up through the sky, and then back down underground. But of course, that problem, which would solve the problem of predictions in the sky, comes up with a problem that doesn't allow for time zones. But all you have to do is look at this panel where we have people in the UK, and Australia, and in North America to know that time zones invalidate that option. Literally, the only thing you have to do to invalidate the flat Earth is pay attention to how it looks when you're outside at night in two significantly different locations on Earth. That's it. The entire thing fails. And what flat earthers have, like I said, is a bunch of post hoc rationalizations coupled with a near total incomprehension of all of modern science and the actual model that they purport to be attacking. There is actually no understanding. This is one of the reasons why when you actually ask people who know about the scientific aspects that flat Earth tends to talk about, things like weather, astronomy, geography, even just basic math, the people who know about those things have trouble even comprehending what the flat earther is trying to get across. Because the flat Earth model, it's not even wrong. It's not coherent. It is self-contradictory. It can't predict weather patterns. It can't predict anything. So all I would like really for the flat Earth is just to do a couple things. Actually explain and predict observations in the real world to at least the degree of accuracy that the standard model would allow. And then also maybe as for bonus points, explain things like spherical excess or the fact that lines of longitude continue to get closer together after crossing the equator. So if you're going from north to south, they start getting bigger and bigger, but then they get smaller and smaller again. And you don't have to be a NASA scientist or a fancy navigator to do this. All you need to do is to be able to use a astrolabe and sight the sun on various stars, be in the southern hemisphere, just be in Australia, say, we have someone here who could do it, drive 100 miles in one direction. You don't even have to trust your car's odometer. You can take your own little mile marker and see what happens to both the time of day as well as the stars. And you can check all of these things, latitude and longitude, on your own. You don't need to trust anyone. Yet flat earthers only ever seem to do it in the northern hemisphere, if they do it at all. So I don't really think I have anything else. It's just the entirety of the flat earth contradicts everything we see about reality. It fails to make any predictions, and flat earthers themselves either are unable or unwilling to do any of the experiments that could either confirm or disconfirm their ideas. That's it for me.
All righty. Well, I am Leophilius, otherwise known as Leophilius. Most people just call me Leo. I do have a YouTube channel. I tend to focus more on astrophysics, cosmology, and quantum mechanics, but when I got the opportunity to engage in a panel discussion, 3 versus 3 on the flat earth, I had to do it. While this might sound rather boastful, I'm going to be quite honest. I don't feel that this is going to be a debate. I feel that myself and Paul and Dapper are going to spend the next roughly hour and a half to 2 hours educating 3 people who either A, are so illiterate and so incompetent that they can't actually understand all of the evidence for the Earth being a sphere, or they know that it's a sphere, they know that they're wrong, but they'd rather be a Poe and troll on the internet for attention. The thing is I could go on about all the evidence and all the reasons we know that the Earth is a sphere, but instead of doing that, I would just say to anyone who thinks that the Earth isn't a sphere or a spheroid, you don't have to pay attention to all the evidence that's out there. You can just do the experiments yourself. You don't have to pay attention that roughly, 1,300 years ago, Eratosthenes discovered that the Earth has some form of curvature on its surface, because when he observed an obelisk in 2 different cities on the surface of the Earth, he noticed that at the same time of the day, the shadow that they cast was different. indicating that at 2 points on the surface of something with curvature would give that result. He actually paid somebody, I believe, to walk out what that distance would be and utilize that distance and the difference in the shadow to calculate within, I believe it was like 15 or 20% accuracy, what the curvature of the Earth was. But you can ignore that. We could ignore all of the people, all of the sailors that have been sailing this planet for thousands of years and all of the methods they had to use to accurately navigate across the planet that involved the planet being spheroidal rather than flat. We could ignore all of that. We could ignore all of the pilots that have navigated this planet that have to utilize the same exact data that you would expect to observe if you existed on a planet that was a sphere and not some flat plane. We can ignore all of that. We can ignore time zones, which indicate that we are on a planet that orbits a star and that only 1/2 of the planet roughly is receiving sunlight at any given time. We can ignore all of this data and just go out and do the experiments yourself. Try to sail from one point on the planet to another. Try to sail from Australia to Japan. And you will notice that the only way you could accurately do it is if you assumed that you were on a sphere. Try to fly from London to New York, and you will realize that when you want to plot out your path, you're going to have to assume that you are on a sphere. You can even ignore the fact that Einstein's general theory of relativity, one of the most accurate and most predictive models that humans have ever developed, tells us that the Earth is a sphere for the same reason every other planet humans have ever observed and every other star or black hole or neutron star or other subgalactic object that we have observed is a sphere or spheroidal because of the result of hydrostatic equilibrium between gravity pushing inward equally on every point on that object's surface and the resistive force of the matter that makes up that object pushing back outward, thus resulting in a sphere or a spheroidal object. We can ignore all of that. We can ignore all of the mathematical, the observational, and the experimental data, and you can just try to live in the real world utilizing a flat Earth model, and you will find that every single time you will fail, and you will fail miserably. So I don't see this as being a debate. I see this as being, you can either admit that it's not that you don't have a model, it's that any model that you could bring that would substantiate your position is going to be wrong, or you can engage in what I would consider to be dishonest and or disingenuous interlocution trying to defend an obviously wrong worldview.
Very interesting, gentlemen. We are excited to go into the open discussion portion. Want to let you know, folks, our guests are linked in the description. So if you want to hear more, you can hear more from our guests. We really appreciate them. And so they're linked in the description, whether you are listening via YouTube or Twitch. We also put the links in the Twitch panels now for our guests. And also, if you're listening to Modern Day Debate via podcast, you can find the guest links in the description box for the podcast episode. So we are really excited to jump into this open discussion portion. And so, gentlemen, we assume you'll be your regular, polite, and respectful selves. And so thanks, gentlemen. I'm sure this will be high energy. The floor is all yours.
I think we should start with the flat earthers who didn't go most recently. So
you're saying we can have a come back then?
Yeah, I would like you guys to go first since we just spoke.
Okay. Well, me personally, I've wrote down 3 bits. I think it was you, Dapper, that said about an explanation of, was it spherical excess?
The spherical excess, I said, would be a nice bonus that match the accuracy of our standard models for almost anything to do with geography or astronomy.
Okay, so can I take that
matter.
spherical excess, the explanation of it?
Go ahead. I would love to hear an explanation.
Spherical excess, as you understand it, would be an excess to the angles of a triangle.
Correct.
I.e., a triangle having more than 180 degrees.
Yes.
Right. Now, in Euclidean geometry, there is a proof in mathematics, a lot of people will know that a triangle has 180 degrees. It's the basis of trigonometry as used practically for measurements of things. So when they are measuring
just really quickly,
triangles,
everybody in the chat is saying that the stream is buffering, and it's buffering on my laptop.
Oh yeah, I'm seeing it buffer too.
Okay.
Okay, yeah, it did come back a little bit. So
It'll definitely improve. What I found out just recently, I just found out that I can't tweak Zoom too much or it does this. So it will go back to normal in about
awesome.
10 seconds, if not already. Sorry about that,
That's
guys.
good. No, it's all good. It's all good.
All right. So sorry, Bev, what were you saying?
So the triangles, there is a mathematical proof within mathematics, geometry, stating that triangles only have 180 degrees. Now, when you are out and realistically at the top of a mountain triangulating positions, you are measuring angles, sighted angles from point to point, thus making straight-sided just an angle, like any angle, measured angle has straight sides. So triangles have 180 degrees. So I would say to you, spherical excess is a triangle with more than 180 degrees, and that is impossible because there's a proof.
It's routinely measured in land surveying.
Sorry?
It's routinely measured in land surveying. So if you say it's
they measure
impossible,
triangles with more than 180 degrees in land surveying. You think that actually happens?
Yes, because they report their results. So if you want to say it doesn't happen,
it doesn't happen.
Then you're going to have
a mathematical proof, Dapper.
You're
the one that's making the claim.
There's a proof for Euclidean space, but Euclidean space is not the way that surface geometry is going to be calculated on a non-flat surface.
These sighted angles, Dapper.
Can I make just a really quick statement? Most physics, especially once you start getting into advanced classical mechanics, and certainly once you're into relativity and quantum mechanics, you're not using Euclidean spacetimes.
When you're surveying, in land surveying, yeah, you do. You use Euclidean geometry.
Yes, in land surveying,
absolutely.
Yes, you do. That's why I specified what I said. I just wanted to make that clear.
That's what we're doing. We're sighting triangles, right? In surveying.
Right. But when large-scale land surveying is done, and the results are put into tabulated tables, there is in fact actual spherical excess reported in all large-scale land surveying.
It's impossible. Dude.
That's great that it's impossible, but that's what's reported. So what you need to do now is explain why it's reported, not repeat that it's impossible, because it's happening. You can say all day that it's impossible, but if you actually look at the results of large-scale land surveys,
triangles only have 180 degrees.
Okay, so I'm just going to assume you don't have an explanation, which is great. Does anyone else?
I do have a proof in mathematics that triangles have 180 degrees.
You have a proof that in Euclidean space that works. We're not working on a Euclidean space, and you don't have an explanation.
Can you show me then? Can you show me this, please?
Yeah, I'll tell you what. I will pull up some reports with spherical excess.
No, and then can you show me, please?
I did also want to say really quickly that you're saying that it sounds like you're saying that spherical excess is something that's mathematically impossible. Under traditional assumptions in a flat Euclidean space, yes, but, and I'm reading this from Wolfram Math World, there's a theorem here that's an equation that defines spherical excess.
Yeah.
We're
talking about sighted triangles in surveying. You go up to the top of a mountain and you sight 2 points with a theodolite and you measure the angle. You then go to the other point and do the same, and you do that 3 times. That's triangulation. You're measuring 3 angles for a triangle. Those are sighted lines. They're straight lines. That's a triangle with 180 degrees.
Of course.
That's how I'd explain that.
Yeah, well,
it's just to say that you can't measure straight. Sorry,
let me just real quick. So if you're using triangulation, right, the only reason it will work is if the lines are straight. Now, if you try to triangulate 3 points, right, and you do this, and you curve these 2 points in any capacity, the triangulation will not work and you will not know where you are because of how triangulation works. So when you're saying, oh, we've got spherical excess, which is impossible because if the method you're using is to make a triangle and you make a triangle, it won't have spherical excess.
Wait, hold on. When you say it's impossible, what do you mean? What kind of impossibility are you referring to exactly?
in reality.
Like physical impossibility, metaphysical impossibility, logical impossibility, because I can give you literally the equation for it. So obviously it's not
but equation's
possible.
not reality.
So
wait,
hold on, really quickly. Can you tell me what an equation is?
It's not. Can you hold an equation in your hand?
That doesn't answer my question.
Well, hold on.
Can you tell me what an equation is?
Hold on. Reality. Now, when you say triangulation, triangulation is not something you can hold. What you can hold is physical objects that are straight. And then when you measure those physical objects, they will adhere to certain laws, right? Like an equilateral triangle, they'll all be the same size. If you make one side bigger, they don't work like that. Okay, so when you start making shapes that aren't shapes, the laws in which reality works don't apply.
You know what? You know what? 100%. You're correct. I'm not even going to try to disagree or get into things like Riemannian geometry. But yeah, 100%. You're correct. I was wrong. Thank you for correcting me. I don't want to get caught up in that discussion. I don't think it's relevant to the point.
I mean, geometry is how we tell shapes. If you don't have the geometry to tell a shape, right? So if you don't know what a straight line is, and you can't establish a straight line, then you can't say that another line is curved and the line the thing you're on is curved. So the first thing that comes is the establishment of the proofs in which we will use to determine shape. We're not 100%. We're not just going to go back and forth, flat Earth, ball Earth, show me why, tell me, explain. We're going to be like, look,
100%,
this is reality, and let's use the reality to determine.
Yeah, 100%. You're 100% correct. Yep. Anybody else?
Yeah, a triangle on a globe, the sum of the angles of a triangle on a sphere is 108 degrees plus f, where f is the fraction of the sphere's surface that is enclosed by the triangle. For a positive value of f, this exceeds 180 degrees. So it does take into account that the Earth is curved.
Not sighted.
Okay, so here are some cited examples. Are we ready? So in 2011, the USGS conducted some surveys of US area and observed in numerous cases.
This is the United States Geological Survey, correct?
Right.
The
United States Geological Survey, who periodically go around the United States measuring distances between various points to keep maps and geological survey, what's in the rocks, accurate for the entire United States, because it's important for lots of things in science as well as industry. So they measured actual spherical excess in this measurement in 2011, ranging from about ½ a degree to just over 2 degrees. Why did they do that? Are they lying? What is the reason that when the USGS surveyors went around in 2011 in this report and actually went around getting spherical excess numbers that are always positive, at 0.76 degrees, 0.78, why is that?
Are you suggesting that a triangle drawn on the surface of the ground will have more than 180 degrees?
That USGS surveyors, who are identified as Elk, Taylor, Browning, and Dick,
I'm just going off mathematics.
Measured that. So why is it that using high precision theodolites, which is what the USGS does for their land surveying, that are accurate to within very small fractions of an angle, why is it, if it's impossible, that it happened? You have to have an explanation.
I haven't got a clue. Like, it's geometrically impossible. I haven't got a clue how it happened.
Well, it's not geometrically impossible if the Earth is actually a globe, because that's actually a requirement.
No, triangles only have 180 degrees. That's a pretty simple.
Off the top of my head, no.
Well, you do that. You do that.
I can't see the second thing you're holding up, Bev.
Oh, you measured the straight sides on the inside.
But those don't form a triangle.
That's not a triangle.
No, those straight sides that you're talking about aren't forming a triangle. They're forming two.
That's how you measure the angle, though.
Okay, but that's not how you do it when you're land surveying, because you can't look through the Earth.
Yeah, exactly. That's why I said straight line of sight, straight line, triangle, not curved.
Wouldn't
So
you just...
then why is it that the USGS is reporting spherical excess?
I don't
Okay,
know.
if the USGS if they reported that Santa Claus was real, we could care less. Okay, so if your entire
interesting, but they're not.
Wait, come on, don't interrupt. If your entire argument is that somebody told me spherical excess, I believe the Earth is a ball, and we're sitting here with logic and demonstrations of how triangles have 180 degrees and are two-dimensional shapes, right? And when you bend them down, you move into the third dimension and are no longer using the rules in which they apply to. So all of your information will be wrong because they're based on not reality.
You guys don't
so
understand higher order geometry, do you?
You'll also remember that when I finished my opening, I said that would be bonus points. In fact, none of my opening was really based on that. It was just something extra that I would really like, would be an explanation for spherical excess.
Well, it's just the first point I always wanted to bring up.
But again, I have yet to hear an actual explanation as to why spherical excess is always reported, other than conspiracy, which is not an explanation that can simply stand on its own. You have to demonstrate that there's
I've never reported triangles having more than 180 degrees.
I've never seen your paper reporting your work in surveying, but I would be very curious to see when you do, in fact, get a team of flat Earth surveyors out and go do some proper controls to actually go see what you guys measure.
What do you mean flat Earth surveys? I've said at the beginning, just reality, right? I just come from reality. I will use surveying techniques and methods because it is reality.
Okay, well, when you guys get together, do your surveying and write up a paper, that'll be really interesting. And I will make sure to read it. And I'm sure that there will be plenty of people who go out and reproduce the experiments and see if they get the same numbers. That'll be fascinating. Until then,
it'll be science is what it'll be.
Yeah, until you actually do that experiment.
Geometry.
All the measurements we have of any significant distance on the Earth include measurements of spherical excess. Now, you guys don't have an explanation, that's fine. Come back and get one.
Are these distances, are you taking a straight line in between these two distances?
They're cited, so unless there's significant atmospheric problems, which they will account for and usually not measure on those days, yes, they are within that margin of error. A straight line from one theodolite to another.
Hold on. A distance. If I have a distance, like if we're talking the distance between 2 points, are you going to use anything but a straight line and the shortest distance between them to get a distance?
Wait, hold on really quickly. Can I ask a question?
Well, this is a pretty big point here, man. This is a big point.
Can I ask a question? Yeah, and that's why I want to ask a question. What kind of manifold are these 2 points defined on?
What do you mean manifold? They're in 3D.
He's asking Dapper.
Okay. In 3D space, but what kind of manifold are we talking about?
3D space is the manifold, up, down, left.
Yeah,
right.
but what's the structure of that manifold? I do.
All right,
because that's what we use.
I just wanted to make sure that Flat Earth Rossi got a chance to speak now that we finally got him back. So go ahead, Flat Earth Rossi, the floor is all yours.
Thanks, James. I was just trying to add my 2 cents in to the actual discussion quite a bit there, because they're talking about navigation, which, as we all know, was traditionally done with compasses and the observation of Polaris, which Polaris happens to align with the North Pole star, and everything in navigation was related to Polaris because it's the only fixed star. As we notice, all the other stars revolve around it. And so these navigators, that's what the latitude line is on a map, is a circle. It's drawn with a compass and it's measured with a magnetic compass. That's how you draw a circle. So anybody trying to draw a circle based on navigation, they're using a compass. That's what the east-west line is. It's a circle. But if you're trying to do a triangle, then how are you going to measure a straight line in any distance apart from exactly north-south? North-south is the only straight lines you'll get using a compass, using any form of navigation that they've known traditionally. So anytime they try and make a triangle, the only way they're going to know a straight line is by going in a big curve. So when you make a triangle from 3 distinct points using one straight line and 2 curved ones, well, the angles won't add up to 180 degrees. That's all I'm trying to say right from the beginning. Thanks for the time.
Yeah, but we're agreeing that what add up to 180 degrees because of the curvature.
And other than the equator, no line of latitude is something you can follow without turning.
This was the point I was trying to bring up with right the hand, is that you can have 2 points on a manifold, but the minute there's curvature in that manifold, you no longer use a line to define the shortest path between those 2 points. You use what's called a geodesic. And these are used all the time in Riemannian geometry, where a triangle can certainly have 3 angles to add up to more than 180 degrees.
Wouldn't the straight line go through the ball?
No.
Okay,
Yes,
so
it
if you
would.
had a ball. Okay, hold on. I got a ball here. Now, I could build a bridge over it, right? Now that bridge would be curved, right?
Yeah,
And I
that
can
would.
drill a tunnel through it. That'd be a straight line, right?
Yes, it would.
Okay, so when you say a straight line on a sphere is following the surface of the sphere, you're wrong. The straight line would be like the radius or the diameter, right?
That's not what I said.
Okay, so you can't have a straight line on the surface of a sphere. That was my point.
Okay, so
Wait, hold on.
Cool.
What? You can't have a straight line
If you
on
had
the
a
surface.
straight line, wouldn't it go off the sphere?
If the line were tangent, yes. Yes, it would.
No, if it was curved and not straight.
If the line was curved,
Well, wouldn't it have to curve to follow the ball?
to follow the surface geometry, yes.
Okay, so then it's not straight.
Depends on the geometry.
So what I'm getting here is that I think we have a group that doesn't actually understand topology in the mathematical sense, but maybe I'm wrong. So I would like to, I'd like to find out. So,
Can I get the basic facts then? Just a quick one.
well, I want to find out if we know enough about topology for.
We want
for
to
this
do the
conversation.
basics. I want to make sure we have a
This is very
direct
basic.
understanding of the very basics of an
I've been
angle.
talking about the basics, and I don't think anybody's been following
so-
me.
An
So
angle. Can we get an angle is between 2 straight lines?
What the angle is between 2
Yes,
straight.
an angle is the measurement in between 2 straight lines.
Well, wait, what? Can you say that one more time, please? I'm sorry.
Angle is the inclination between 2 straight lines. Imagine a circle.
No, I mean, I
and
know
then
what an angle
divide
is.
it into
Your definition
360,
just
and
confused me.
each one of the angles would be a division between 2 radius lines.
Wait, are you talking
That's what
about
an angle is, right?
Wait, you're talking about radians.
I'm talking about an angle,
Yeah, like radians.
like 2
measured
straight
like-
lines.
Never mind. I guess I'm out of my depth. I don't know what.
No, we're
I-
talking about the angle, dude, not the circumference, right? Yeah.
Maybe we can address another part
Well,
that
the
Dapper
Phyllis.
Dino brought up about navigation,
Yeah.
because he's saying that they've been navigating for thousands of years using what they call planetary geometry, whereas that doesn't work that way at all. As I said, if you're drawing latitude lines in ever increasing circles around a center point, the North Pole, then that's why they keep on expanding. But this is why when they say they get to the equator, things go pear-shaped, because they no longer match their expectations. And the reason for that is because they've lost their focal point, which is Polaris. The Polaris was always their
what?
focal point.
When you say
Polaris was always the focal
when you
point for
say
navigation.
pear-shaped, what do you mean?
Yeah.
Well,
That's what I'm trying to
because as soon as you get so far away from Polaris, like anything else that disappears due to distance and perspective, is that the further you get away from something, the lower it gets. It doesn't mean you're going over a curve. It just means that visually it appears to get lower and lower, which is how the sun sets. It's getting further away. So you're getting further away from Polaris till you reach the equator, which is the point they've drawn on their charts, a big circle around the North Pole, which is where Polaris disappears from view. So that's why measurements get pear-shaped, because they've lost their point of reference. They have to start using something else. And as a result of that, as a result of Polaris disappearing, that is when they believe they disappeared over a curve. This is ancient superstitious people thinking that convergence of perspective means curvature because it's gone below the horizon. It hasn't gone below, it's just disappeared into it.
So Ross, why don't you use navigation tools from antiquity, which are available? You can simply get them. Learn
Well,
how
I'm
to use them.
Australian and I can't see Polaris, and I'm not into ocean
But you
navigation.
can
Why
see the
can't-
southern celestial pole,
Why
but that is a
can't
good
you see
question.
Polaris?
There is no southern celestial pole.
Why can you not
Well, then-
see Polaris?
Yeah, what? Those are both good
As I
questions.
explained to you, once you get a certain distance away from anything, even if it's a pole star, it's going to disappear from view.
That's not necessarily true. That is not necessarily true.
The stars do the same thing.
No, they
Everything
don't.
obeys laws of perspective. Of course they do.
What are the laws?
They do obey the law of perspective.
Hold on. What are the laws of perspective?
The laws of perspective means if you get further away from something, it appears to get lower if it's really high up above you. Otherwise,
No, that's a description. What's the law?
The law? Well, it's all a visual law, isn't it?
No. Like, for instance, if I gave a law of motion, I might say force equals mass times acceleration, and then I could measure each of those with units. What is the actual law of perspective?
Not a physical measurement of a force. We're talking just about a
Then
visual.
it's not a law.
Of our being able to see.
We're talking about science here. In science, laws are equations. If you don't have an equation, you don't have a law.
No, equations are just wizardry. We don't need wizardry.
Wait, hold on. What do you mean equations are wizardry? Wait, no, hold on. Okay, really quickly. Can I ask you a question? Just a very, very simple question. Hold on. Is 2 + 2 = 4 a true statement or not?
2 + 2 what?
Does 2 + 2
2
= 4?
2 oranges, does that equal 4 apples?
Does 2 + 2 = 4?
You're talking abstract.
Why are you not answering the question?
Because 2 + 2 what?
Why does that matter?
You're confusing him with your sorcerer's ways.
No, you're talking abstract stuff of
Wait,
non-reality.
you think math is not abstract?
I'm saying it is abstract.
Yeah, it's very abstract, of course. That doesn't mean it doesn't work.
You've got 4 apples. If you've got 2 lemons + 2 oranges, you don't have 4 apples.
Yeah, but you still have 4, right? You still have 4 objects.
Things.
Yeah, you still have 4 objects. So 2 things + 2 things will give you 4 things, right?
Correct.
Okay, so 2 + 2 = 4.
You could just say you don't have 4 things. You have 1 individual unit, 1 individual unit, 1 individual unit, and 1 individual unit. Now,
I'm glad that we've changed 2 + 2 to 1 + 1 + 1 + 1, but it still ends up equaling 4.
No. Hold on. When you're saying math, right? Now, when you say 1 is a description of like A would be in algebra, A would be a unique thing. Okay, 1 would, if you're describing a unique thing, right, and describing another unique thing and add them together and don't get a new thing, you can't label it a new thing. So when you say 1 + 1 = 2, 1 pile of sand and 1 pile of sand equals 1 pile of sand. So you're just talking an abstract number theory. You're not proving anything of the world. But if this makes you feel better, then go for it. We're trying to establish the shape of the earth. Can I try to conceptually describe how many grapefruits I have on my table?
Can I ask you a quick question? Do you know what mathematical logic is?
Do you know what is the definition of mathematics? What is that?
That's not what I asked you. Do you know what mathematical?
How am I supposed to know what the logic of what? You said mathematical logic. That means the logic of what?
I asked you what mathematical logic is, and you're asking, the logic of what? I don't.
Well, you're saying logic. Logic doesn't need something behind it, unless it's illogical. So you have logic and you have illogical. So when you
so wait, logic doesn't require axioms.
Logic doesn't need. What are you going to say? You have Shakespearean logic.
Right.
No, there's logic.
Right the hand.
And then there's illogic.
Right the hand.
I have a question. Chance to respond, and then what I want to do as well is Paul has been patiently waiting, and so given especially Paul's interesting background as a pilot, after Leo has a response here, I'm hoping to hear from Paul. If you have anything, Paul, on your mind, go ahead, Leo.
So, right the hand. Just a really quick question. Do you know what the difference between classical and non-classical logic is?
You're just making stuff up right now.
Okay, no, I'm literally not. You can actually take graduate level courses in like classical and non-classical logic at universities.
That's great. You think there's 2 logics. There's logic, which is based on reality, and then there's illogic, which means it's not reality.
I don't know what to say at this point.
The statement is either logical or it's illogical. There's not degrees of logic depending on your bias or graduate degree. Sorry, man.
Well, no, but there are different types of logic, yes.
Paul, what have you got? If you have anything, Paul, I don't want to force it.
Yeah, I'm just going to address what Ross was saying about the North Star. Yes, once you get below the equator, you can't see the North Star, but sailors back in about the 1700s, they used to use the Southern Star, which is Polaris Australis or something along them lines. So they used to navigate by that. You live in Australia. You are in the perfect position to test whether the navigational charts follow the globe. Because if you get a navigational chart, your longitudinal lines will get narrower as they go south. Our longitudinal lines get narrower as they go north. So if you get the navigational charts for Australia and check that out, that will follow exactly what is on the globe, and them lines will match up exactly where they are in Australia.
Well, that sounds reasonable by way of ancient superstitious navigation of things, but
no, that's the navigation that is used today.
In reality, there is no southern pole star that you called it. That's actually called Sigma Octantis, and it's not visible to the naked eye. And it's allegedly supposed to line up in some fashion with the Southern Cross. Now, I see the Southern Cross every night of the year, all year round, in roughly the same position. Its angle does change, but what doesn't change is that by the morning, when I see it in the southeast, when it first comes into view at dusk, is that by morning, when it starts getting bright enough, the stars disappear, it's over to the far west. Now, in the flat Earth model, that works perfectly well because all the stars rotating around Polaris means that because we have time zones, and time zones are ruled over by the sun, wherever the sun is directly overhead is your local 12 p.m. And so as it takes 24-hour segments to go right around the whole world, the other half of the world is in night. And so as the stars are basically working in unison with the sun, that means that the other southern continents will see the same stars that we see during their local nighttime. So for me to see it going to the west is exactly what you'd expect to see of all the stars rotating around Polaris above the stationary planet Earth. The only reason they appear to be going in the opposite direction is because in the south we have our back to Polaris and we're looking at them in the different direction. So when you look at anything rotating around above you, if you turn around and look the other way, it will appear to be going the opposite direction, but they're all still going the same way.
It won't have an additional rotational pole unless you're looking at a 3D object with more sides than would be available to a hemisphere, which is all a dome over a flat Earth can be. You need to have an entire sphere of the Earth in order to have two rotational poles. Otherwise, what you would see, as you would see if you look at my animation here, where I'm centered on the South Pole, if you were standing far north in Alaska and looking at the stars, you would simply see them sweep across the sky with no rotational pole other than the North Star. Or actually, in this case, it would actually be Sigma Octantis, because I have this centered in a way that actually makes sense for the Southern Hemisphere on Antarctica.
But you've got the sun going the wrong way.
No, I don't. It is actually still going east to west. But if you actually look at the rotation of the actual sky and the objects in it from the Southern Hemisphere, they rotate to your vision the opposite direction, which is what I've got going.
But that's not the way I see them. I see them going from east to west as well.
I might have it X mirrored because of my software. Let me fix that. Sorry, that might be the case. I might have it X mirrored. I don't know. But yeah. No, it's coming.
Yeah, that's what I was saying. You just got them going from right to left, whereas I see them going, as I'm looking south, from left
but you're
to right.
looking up. You're looking up in real life. You're currently looking down at my map. So yeah, it is going to be reversed.
Yep.
So the thing is, it's not hard to figure out a geometry that works with the sky. It's really not very hard. The sky is what's called a celestial sphere. It's called that because celestial means heavenly, and the things in the sky are, according to lots of conceptions from the ancient world, the heavens, that's what you call them. And it's a sphere because you can map every fixed star to a particular location on the sphere, and they all rotate together through the year.
Doesn't make what it is. You can call it a sphere,
the thing
but
is,
it can still be a flat
it's not
plane.
just the thing. It's not named arbitrarily. It's named because every single object on that sphere has a particular location on the sphere that it always appears on in the same relation angularly to all the other stars on the sphere. These are not the planets or the sun or the moon.
Well, that makes a mockery of the globe model, though, doesn't it? Because you're saying that
it depends on the globe model.
The Earth is racing around the sun. It goes about 1.6 million miles every day as the sun is moving itself 500,000 miles an hour. So all the angles of all these stars means that you are saying that every single visible star is moving exactly the right amount, right speed, right angle, right velocity.
That's
all
not
around
what's happening.
Ross, so let's say the Earth moves 1.6 million miles in a day, right? How far is it to Proxima Centauri, which according to the standard model is the closest star?
It's about 70 miles, the same place every star appears, because that's where every
No, I said
visual-
according to the standard model. That's great that you have a different answer. But according to the standard model, how far away is it?
I really wouldn't know, because I've grown up from childish fantasies. Can you tell me how many billions
25
and
trillion miles.
Hold on.
Right,
We
so-
do want to hear a response. So just to be sure that we're not cutting each other
Well,
off.
the response was, I don't know.
Well,
Oh, yeah, it's
well,
25 trillion miles.
We do
trillion
wanna,
miles?
listen. I don't like that. So just if I say
Okay.
we need to hear a response from somebody, we need
that's
to
fine.
hear them finish,
I
and they'll do the
apologize.
same for you, and I'll make sure that that's the
sorry.
case.
So Ross, what is
25
that?
trillion miles. Who measured that? With what tape measure? What laser measurement device? How did they actually measure this? You know, this is what I'd like to know. You tell me who came up with this measurement and how they did it.
Okay, well, Ross, that's a separate question. Right now, we're trying to get at why it is that the relative lack of apparent change in the location of the stars throughout the year relative to each other is in fact not a problem for the standard model. Now we can figure out how
you had to back engineer this standard model of billions and trillions of miles to explain the lack of visual parallax, which doesn't need to be made up if you understand that all the stars move as one body around Polaris.
Maybe, but we're still at the point where we're explaining the actual model as it exists. Because here's the thing, this is to all the flat earthers out there, not just on this panel. If you want to attack a scientific model, you have to first understand it. And it is evident that Ross here does not.
I understand your model perfectly, mate. That's why.
Ross, do you think that there should be a difference in visual angle between us and Proxima Centauri after one day traveling 1.6 million miles when the actual distance to it, according to the model, is over 1 trillion miles?
Well over.
According to the model. So that means you have to make up this fantastic belief in order to explain away.
Even if that's what we're, even if that's what happened, Ross, even if that's what happened, even if what happened was we just made it up. Look, Ross,
you really believe.
All right.
Even if it were made up. Sorry.
All right. Let's hear from Dapper, and then I promise we'll come right back to you, Ross. Go ahead, Dapper, and we'll let you finish, and then we'll come over to
So the point here is, even if it were made up, even if someone just pulled these numbers out of nothing because they helped the model work, it still means that your supposed objection to it fails because the model predicts what we actually see. Now, if you want to have a separate discussion as to how this distance to celestial objects are measured, that's great. But what it still means is your objection that the night sky doesn't sufficiently change based on the heliocentric model is incorrect. The heliocentric model accurately predicts the location from day to day of every star and planet in the sky. That's all I have.
Well, there you go, though. You're saying that it accurately predicts it, but you're based it upon a false notion, which you refuse to acknowledge is the most important reason why you have this belief in the first place, because you can't tell me who did it and how they did it. You just believe they did it, and you have to have a belief, blind faith in this model for it to actually work for you. Whereas we can see with our own eyes. We can't see trillions and trillions of miles away. We can only see a short distance. We can see maybe 100 miles if we're lucky with the naked eye.
I routinely see many trillions of miles.
No, you don't. You believe you do because that's what you've been told to believe, but you cannot see that far.
Yes, we can.
If that light was traversing that much distance, then the entire night sky would be absolutely super illuminated by all the light of all the different stars.
No, it wouldn't.
Why?
At all different moments. Why would you just see tiny dots then?
The light, the whole
If
night sky wouldn't be
miles away,
illuminated.
they vanished into nothingness. It would be pure blackness, or you'd be pure white, bright, lit everywhere.
Ross, are you unaware of the inverse square law as well as the fact that there's a cosmic horizon?
The inverse square law would render them into invisibility.
I'm sorry, say that again. I didn't hear it. I'm sorry.
The inverse square law would render them into invisibility immediately. It's too far.
Right, which is why things that are too far away are in fact dim, but things that are extremely bright and not too far away are visible. And not too far away, given how bright some of these objects are, turns out to be many trillions of miles.
Well, you brought up the inverse square law. You tell me how it works. Does this mean that if I've got a bright torch 1 foot away from me and I move it 2 feet away from me, it's only half as bright? Where does this inverse square law?
No, it'll be about a quarter as bright.
At what distance? It's a quarter as bright 2 feet away.
Yeah, because if you're doubling the distance, then you have doubled squared for the brightness. So, or sorry, for the
So,
decrease in brightness.
by the time I move it 20 feet away, it should be completely black, and yet you can see it.
No,
A torch.
no.
So if you move it 20 feet, you've moved it 20 times, right? So what is 20 squared?
400. What's the point?
So if it's 400 times as dim, is that 0?
Pretty much. Yeah.
No, it's
only a
not.
little
It's
dim torch.
measurable.
Yeah, it's definitely measurable.
It appeared to be the tiniest little dim spark, as opposed to the bright.
that's
light.
wait,
Do you understand how bright objects in space-time are? If you could rank stars on a scale from 1 to 7, with 7 being the brightest and 1 being the dimmest, the sun would be a 3. Look at how bright the sun is during the day. Take an object that's 1,500 times as bright as that and put it 2,000 times further, and you will still be able to pick up that object in the night sky.
Are you
So
saying
what
the
happened
sun is not
statement?
is the sun not the brightest thing we know? Are you going to say
No.
there's something
The
Brilliant,
brightest
absolute
the
brilliance.
brightest object that we've ever measured? No, that would be a quasar that's like 900 trillion times as bright as
Okay,
the sun,
hold
that
on. I'm
lies
asking-
about
I'm asking
13
you.
billion light years away.
Who's the you there? I'm sorry.
Leah Phyllis, you
Okay.
yourself, you've seen something tens or 20 times brighter than the sun?
Yes.
Or is this just a story somebody told you and you're believing?
No, I've seen it. I've seen the pictures of it.
What is you've seen with your own eyes? Oh, you've seen a picture of it. Was
Of
the
course.
picture brighter that hold on? Was the picture that you saw so bright it burned your eyes, or was it not as bright as the sun?
Wait, is that how you think pictures work?
No. Well, hold on. How do you think brightness works? You told me you saw
Wait,
something.
but
10
you
hold
think the
on,
way
hold
that
on,
brightness
wait,
works in
let me get this
reality
out.
translates
No,
to
time out.
pictures.
Let me get this out. Let me get this out. You said I've seen something 100 times brighter than the sun.
Much
and then
brighter.
you said, look at this picture on this piece of paper, which is not nearly as bright as the sun. And I'm
Of course
going,
not.
well, so then you didn't see something brighter than the sun. You saw
Yeah, we
a
did.
picture, and then you believe that picture somewhere out in your imagination land, there's something brighter than the sun.
So
But
the
in
universe is
reality, where we
imagination
were-
land now?
Well, the sun is in reality. The thing
Yeah,
you're
the sun is in the
saying-
universe, yes.
Hold on.
As is the Earth.
And that thing you've said you've seen
Is a
not-
quasar that's also in the universe. Yep.
and it's
we
brighter than
can-
the sun.
Yes, it is. We can
And
measure
so
it.
that's why I
We
see the
can
sun.
measure its
That's why-
intrinsic luminosity, and the amount of electromagnetic radiation that it emits is 900 trillion times more than what the sun emits. Yes.
Okay,
Why
so
do
you're
you not
telling me,
believe
what you're
them?
telling me is that some little speck in the night sky is brighter than that gigantic illumination ball that comes during the daytime. That's your argument, and
It's
you
further
can stay
away.
with that. It's a good one though.
Yeah,
It was
yes.
good. It almost had
But
some people.
obviously, given that it's 13 billion light years away, it's not going to appear in the night sky as bright as the sun.
Okay,
But
so
if
in
the
reality-
Earth were the same distance away from that object that it is from the sun, that object would be 900 trillion times brighter than the sun is.
Yeah, and
Yes.
if, but in reality, so without the ifs.
No,
when
in
we do-
reality,
hold on,
because
hold on,
we've
I'm
seen
not
it
done.
and
Let
we've
me
measured
interrupt.
it.
Okay, wait. So we're measuring brightness, okay? Now I measure the brightness of the sun. It's off the freaking charts. Now we go at nighttime.
Really
and you
not.
see- hold
Yeah,
on,
it's
hold
not
on.
at all
And
off
you're-
the charts.
Wait. Let me get this
It's
out.
not.
Come on, guys, come on. Shh. I can be the only excited one. If we get too many people excited, it goes crazy. So I measure the sun, right? And the reading is off the chart, right? Then at nighttime, there's this little speck, and we get a reading, and it's barely, it's a dimple. And you're going, you see that dimple? That's 9 trillion times the sun. And I'm going, bro, I think you've been sold some magic beans.
Can I ask you, do you know what the term intrinsic luminosity is?
Bro, do you know what reality
That
luminosity is?
doesn't answer my
That's
question.
a no.
Do you
That's a
know?
no.
Do you know what the term intrinsic
Bro.
luminosity means?
You're creating brightness that isn't there in your imagination. You're
I'm
saying this
only
thing
going to
that's not as
try
bright as the
one
sun is
more
brighter
time,
than the sun.
and more for the audience than anybody. Just pay attention to this. He's not answering the question. I'm going to try one more time. Do you know what intrinsic luminosity is?
Okay, you're kind of doing, don't interrupt, please. I'll answer you. You're doing that thing again that you did with logic. Luminosity or brightness doesn't need anything in front of it. Okay, hold on. When you're saying this thing is bright, okay, that's how we measure how bright it is. Now you say, well, it's further away. It's blah. You know, when we're talking about the brightness, which is a visual aspect, okay, visually, the sun is brighter than anything we've ever seen. Now you're converting brightness into a formula and then making the sun the least bright thing in the sky. That's insanity. That's the wizardry of mathematics.
Wait, what? The least bright thing? First of all, not only do you not know what intrinsic brightness is, you seem to think that we think the sun is the least bright thing in the sky. It's not even close. I am. See, this is what I meant when I said in my
anything about
opening.
Distance. I said nothing about distance. I said brightness.
This
Okay,
is what
now,
I said.
if
This is what I
Brightness
meant.
is related to distance.
Yeah, but here's the thing. You're going to try and convince me that something that is barely visible in the night sky is brighter than the sun. And
Just
how you're
because
going
it's far away.
Well, that's you, but you, okay, when you say, but it's far away, that is you saying this thing is not as bright as the sun, but I believe it is brighter, but it's further away.
No, you do realize
so I work
exactly.
in reality. So
Do you
in
know-
reality, I'm going to say the
Do
sun
you know
is
how
the
we
brightest.
do you know how
Yeah,
we measure
basically, if
luminosity?
you look at the sun and how bright the sun is now, and then move it trillions and trillions of miles away, it's going to look dimmer, but it is still going to be the same brightness as it was when it was close to us. It's to do with the distance.
Yes,
Can you move the sun? Can you move the sun?
The
I
sun
was
is-
using
the
that as
sun
an
is moving
example. That
right
if you
now.
could move the sun that distance, it would be dimmer, but it would still be the same amount
do you
of
know that?
luminosity.
Can you do that to confirm?
Yes, we can. We already have
You
done
can
it.
move the
Astronomers
sun.
do it.
You're telling me
Wait,
you can
what?
move the sun and confirm.
Confirm
How
what?
do you know what the sun will look like 7 trillion miles away? Are you just
Because
using
we
your
can-
imagination?
because
It
we
looks
can look at-
smaller and dimmer.
Because we can look at stars.
Okay, hold on.
We can look at stars that are of the same relative brightness and measure their distance and learn what the sun would look like, since it would have the same relative brightness as the stars is. We can then figure out what the sun would look like if it were that distance away. This is how we measure objects in space-time.
Okay.
You know
when
what we can also
figure
do?
out- When you say figure out, that means I'm going to look at the sun, then I'm going to take a piece of paper and I'm going to take a piece of pen and I'm going to do this. And then after about a minute, I'm going to say that thing in the sky that isn't as bright as the sun is brighter than the sun.
Well, you're being a bit hyperbolic with how
No, I'm
easy
being
you
really
think.
truthful.
Please don't overtalk
That's
me.
what you do.
You're being a bit hyperbolic with how simple you think the mathematics is done. It's not done that simply, but essentially, yes, that's what's done. Most objects that we measure in terms of their brightness in space-time, we measure against the sun. The sun is the standard for our conventional system.
Excuse me, can I just say something here? This is a flat Earth debate, is it not? And yet here we are talking about the lights in the ceiling. Like, we don't look at the lights in the ceiling to determine the shape of the floor we're standing on, do we? So we can look at the stars and the sun and all the discuss its brightness as much as we like, but this is really getting off topic about
Actually,
talking about
I
the flat
can
Earth,
look at the
where we
lights
know
in the
that
ceiling,
water makes
even in a
level.
room. Even in a room, I can use the lights in the ceiling without ever looking down to determine the shape of the room, as long as I'm able to measure the angles to them and notice how they change as I move across the room. It's actually
Gotta
not
love
very hard to.
calculus.
Yeah, it's not very hard to use. You didn't need calculus for that. All you need to
Yeah,
do
but
is
most observation
notice
points are stationary.
you're
so,
moving around
you're
to
not
different
even gonna move
locations.
across the-
if you have a ceiling and you move to different locations and you measure the angles, you can get a actual in 3D map of the ceiling, and then based on that, you can backtrack to where you are in the room and measure the shape of the room without ever having reference to
And determine that the floor curves. Is that what you're saying? That by
If the
measuring
floor
different
curves,
angles
Talk
then
about
yes,
that,
you
please,
would.
please.
Yeah,
Yeah,
if
I
the
think
floor does
make-
curve, you could determine that. Yes.
on a desk and shine a lamp above them and get heaps of different angles of shadows, and I can use a mathematical formula to prove how spherical my desk is. It doesn't
No,
prove that
you
my
can't.
And
You can't do it with a flat desk, no. Now, if
You
you
can.
had a curved desk and you actually moved the camera
No, if I
facing
had a
lines
flat
across the
desk-
curved desk,
if I have a flat desk and I have a fixed lamp above it, and I line up a pile of, just say, batteries, stand them up end to end on their end from one side of the table to the other, and I measure all the different angles of the shadows, I can use a mathematical formula to prove that that desk is spherical.
I
That's
encourage you to
basically
do so. I
Not
await
if
your
the desk is
monograph
not
That is an
spherical.
Elie-Hopkins
with bated
experiment in a nutshell. So it doesn't prove anything. It just proves that you've got a local
Ross-
light source and cast different angles of
So-
shadows on different things.
So
different
here's the thing,
locations.
Ross. You say that you could do this. I say you can't. But the simplest thing to do would simply be to do it. Get a desk, get a lamp, get a camera, get something you can use to help measure angles, and do the experiment, and then publish your results, and then let other
You can do
people
that
check
with a
work.
simple protractor. You can use a simple protractor to measure the angles.
Okay,
and you
well,
could
why
plug
haven't
it into a formula.
Yeah,
Why would I? Because it's ridiculous. You know, I
Well,
understand.
because
that
you
the
think-
But you're
flat-
saying it proves your point, so why would you not have done that experiment that you're claiming proves the point that you're trying to make?
Because it's already
just
been
go out
done.
and do the work.
Aristophanes did it, and he proved that we have a new local sun. He didn't
No,
prove
wait,
that the sun was
he didn't.
93 million miles away.
Aristophanes proved that the surface of the Earth is curved, that it's convex.
No, he proved that
Yes,
different places,
he did.
different locations will have different angles of the sun on the same
Yes,
day
because
the sun's nearby.
the surface of the Earth is curved. Yes, you are correct.
How did,
No.
how did he
Different
come up with
angles
that
because
geometry?
because the angle of incidence changes. Yes. Yep.
So you're saying the desk is curved to give different angles from each different battery from a fixed light source at the same time.
No, it's different on a curved surface.
You are saying that.
No,
That's what
Leo,
you-
can I just
Different
sorry,
conclusion.
can I just ask Leo, how did Eratosthenes come up with spherical geometry when it didn't exist?
I don't think spherical geometry was invented by Eratosthenes. He used simple trigonometry.
That's with triangles with 180 degrees, like I keep saying, Euclidean geometry. You can't curve those lines in triangles.
You don't need to determine that the Earth is curved.
Okay, well, can
simple
I
trigonometry has straight edges. How
can
can
we
you
go
use a
back to
curved
that
surface?
base?
Okay,
was
hold on.
The next point I wanted to go to.
So no, really quick here, Bev, because this will help make my point. You see the curve in the second image you have there in green where it says hump. You see that curved line that you have. Can you draw a secant line through that for me, please?
It's there. The bit where it says hump.
No, the line.
Like, see that little bit there? It's where it says hump. That's the bit above the horizontal that is set by the water level.
I'm trying to make a point.
Hydrostatic equilibrium.
I'm trying to make a point here. The curved line under which the word hump is written.
Yeah, see that little line? It's already there.
Okay. I'm not asking about it. I'm asking a question. Can you draw a secant line through that? Through that curved line.
Drawing there is hydrostatic.
Can you draw a secant line for me?
Line
please?
there. Already.
Do you understand what I'm asking you?
What, do you want to do it?
I can, but it's going to take a second.
Do us a quick drawing then.
It's going to take a second, so somebody else can go while I get it set up.
Okay. Well, that's what I wanted to go to was the because you said something earlier about hydrostatic equilibrium.
Yes, I did.
In a curve or something. But that's the water level is establishing a horizontal plane of reference, right? That's a
level
horizontal is a straight line, right?
No, it's
it's level with the surface of the Earth.
Yes.
Yeah. Whatever the shape of the
What
Earth
does
is,
mean?
that is the shape of level. So
Yes.
saying that water is level provides you with no help. You still have to go out and actually measure things.
What I said was a water level is a tool for establishing a horizontal plane of reference, as is all tools that are called level. They establish a horizontal plane that is parallel to that of the plane of the horizon. All horizontals are parallel to the plane of the horizon.
That is how they're defined. And your horizontal on different locations will depend on the shape of the Earth. If the Earth is in fact flat, then yes, all horizontals will be parallel. If it isn't,
water level just proves that wrong. Water level just proves that level is universally level. That's why we use the term.
Of course, it's universally level. But the question is whether or not level curves.
Horizontal.
It doesn't curve.
That's right.
Why not? How do you know?
It's a horizontal plane of reference. It's easily provable, as is every time any surveyors ever do a job. That's what they use.
Except you don't believe surveyors, because when I report to you the actual finding of surveyors, you just tell me that it's wrong and don't give me an explanation. So please,
you did
don't
just say those surveyors.
Let me finish. Please don't come to me with surveyors when you think that either they're just making stuff up or they're lying or I don't know. But you apparently think that surveying is just nonsense. So I don't know why you're trying to use it on me, but the fact is that whether or not level is curved depends on the shape of the Earth. So saying that it's level doesn't do anything. It's agnostic to the shape of the Earth. Pointing out that level exists helps neither you nor me. You have to actually do some actual out in the real world measurements, which is
can I answer that now, or are you just gonna?
Yeah, sorry.
Level is horizontal. Right? It's not as something you have to prove. It is an established fact.
Is it? Because
yes.
definitions of level don't actually prove that or demonstrate that fact.
Really quickly,
How would you level a circle? Could you level a circle?
Could you level? In a sense, yes. I am sharing my screen. I don't know if James can see it or not, but I can explain how you can do that. Yeah.
Yeah, you can be at a set level above a circle.
In relation to a water level, how can we do this?
So
you can't level a circle because level is an orientation and being straight between 2 points, right? So this is straight but not level. A curve cannot be level. So to level something is to make it straight, not to make it round, okay?
No, you could be level to the surface of the earth. So you could follow the curvature of the earth and stay at that level.
So if you hired a handyman,
just like an aeroplane, when it flies across the surface of the earth, it stays at a set level to the surface of the earth.
Really quick, write the hand. Do you know what a tangent line is?
Line to a circle.
Well, no.
A line to a circle.
That's part of it.
It's really rudimentary, but so
it's a straight line that touches the curve at 1 point only.
Here on my screen, we have a curve. I've got, say, a point on that curve. And what I can do, and this is going to be a little bit, is I can draw a line like that. Is that line level?
No.
Well, first off, define what I would need to do to make that line level.
Make it horizontal.
But it is horizontal relative to...
No, that's not horizontal.
You didn't let me finish. It is horizontal relative to that reference frame. If we were to zoom in on that so that we could look at it here, we would see a straight red line. Would we not?
It's not horizontal.
That's not what I asked you. If we zoomed in on that, we could see a straight red line, correct?
Yeah, it's a tangent.
Okay,
that's what
so
you just
there
said.
is a way.
It's not horizontal.
There is a way to make it horizontal, is what you're saying.
Okay.
So this is what we do on the surface of the earth. This is what happens on the surface of the earth. Water is going to be level along any given tangent line on the surface of the earth.
Don't intersect.
Well, I think you should probably learn a little bit of advanced mathematics because, yeah, it just does not seem that you understand precisely what you're talking about.
This may be a chance to give you guys a warning that we'll go into the Q&A fairly soon here. So if you guys have any concluding points, things that you for sure wanted to bring up and you were like, oh man, this would be interesting to get the take of the other side on, please do. And then in several minutes we'll go.
I actually did.
I got one too, and it's on what we were just talking about. But
how do we explain how every other planet and star and black hole and neutron star that we've ever observed is spherical, but the Earth somehow isn't?
How do you know they are? Have you ever been to any of them? Have you ever landed on any of them?
We've seen them. We've seen them.
You can see them.
Yes,
okay, but you can see the positives. If you could see a truck in the far distance, you see a singular light. As it gets nearer, it starts to break up into the two headlights, a whole body of lights. But at a far distance, it appears to be just one orb of light. So you don't really know what you're looking at until you get much closer. But you've already told us that they're trillions of miles away. Do
you think that electromagnetic radiation is the only way that we detect these objects? I mean, it's the primary method, yes, but it's not the only method. And why is it that all the different methods that we utilize for observing these objects comport with each other?
Just because they look like orbs of light does not mean that we're standing on a similar type of orb for 1 second.
So then how come every other planet we've looked at, and even things smaller than the planet, like the moon, are round?
Well, the only thing we've seen that we know is round is the moon. Anything else is an orb
the sun, Jupiter, Venus,
I've seen with
Saturn,
my own eye,
Pluto,
several
Mercury.
Orbs of light.
Yes.
Orbs of gaseous light, emitting light. Like, how can you have
they have shadows.
You cannot. You're just making
Wait, hold on. What did you just say?
An orb of gas in a vacuum. It's impossible because everything in a vacuum.
Hold on. Can you what does a vacuum mean in physics? Can you tell me what that term means when we're talking in terms of like
nothingness?
No, that's not what a vacuum means.
Well, what does it mean then?
It means lowest energy state. means the ground energy state. It is a field in a ground energy state. That would be a vacuum state of that field. And for matter and energy fields in the vacuum of space, there is a very, very, very small amount of particles present in these fields. So we say they're in vacuum state. They're at a vacuum. That is the vacuum of space. You can curve that manifold, and that is why planets and stars and black holes and neutron stars and all the subgalactic objects that we observe are round given their mass.
So you can manufacture anything out of nothing so long as it fits your agenda that you want to believe in. Whereas in actual reality, if we create a vacuum state here on Earth, we need to use powerful pumps, strongly sealed valves, and solid walls to create a vacuum state. And the minute that seal is cracked the slightest, everything instantly wants to equalize pressure.
Of course.
And so even Earth itself could not exist within this vacuum state and still have an atmosphere unless it had a strong physical barrier protecting us from the exterior lack of pressure.
It does. That's called gravity.
Yes,
it does. It's called gravity.
Hey, it took us over an hour and a half to get to gravity. I think that might be a record for Flat Earth debate.
Gravity in the molten core of the planet. How can that be an exterior? Isn't gravity the molten core in the interior of the planet? How can that
is
be
not what gravity is. Gravity is curvature in the geometry of space-time by the presence of mass energy.
So things that get less and less affected by gravity because of the lack of density as they get further and further away from the field of gravity get held by this invisible container because of gravity with the least effect.
Density has nothing to do with it.
Correct. It's got everything to do with it.
No, mass. Mass is what we're looking for here.
Mass is defined by density per volume.
Not in relativity, no. Mass, no. Mass is a fundamental property that elementary particles hold.
I'm talking about reality, not relativity. You know,
relativity is reality. We use it to observe and study and define our physical models in reality.
Look, you're Ross. You're welcome to overturn relativity when you come up with a model that works better for the things that relativity is used for.
Well, we use relative density, and that easily overcomes your relativity made-up thing to say
no, it doesn't.
Because relative density requires a force of gravity in order to actually cause the emergent buoyant force that would counter the actual downward force of gravity.
Yeah. Relative density is determined by the density of the medium within its in and how much resistant force it has. Tell
you what, Ross, you come up with a better version. You come up with a better version of the buoyant force equation that doesn't use gravity as a term, and get back to
gravity. What is gravity in your explanations, except for it's just a measurement of distance over time?
I literally told you what gravity was. Gravity is curvature in the geometry of space-time by the presence of mass or energy. The Earth is a massive object, so it curves. What that means is that
you're talking about the space in between. Hold on. Are you saying that you can curve the area of space in between my hand? Okay, if you can, hold on. If you can do that, first, tell me what shape the area between my hands is and what shape you're going to curve it into. Are you curving it up?
It would depend on the mass energy stresses present on the space-time in between.
No, the stuff in between. The stuff in between. How are you curving that?
It depends on the stress from the mass energy present in between, because it's
about reality. Observable reality says that thing drops because there's nothing there to support it, to give it resistance.
Hold
so
on.
It reaches a place of sufficient resistance due to its density to stop it from falling any further. That's all you need. You don't need to bend space and time and make up all sorts of nonsense things. Occam's razor says the simplest explanation is generally the most correct one. The most correct one says if you've got sufficient resistance from the density of the medium, then you'll get buoyancy. If you have insufficient resistance from the amount of density, then it will continue to drop until a place of sufficient resistance due to the density of the medium. That's all you need. Nothing complicated, no bendy space-time or anything above that. Just resistance from relative density.
What you said is not correct.
Can you bend the space?
Gravity in that.
If you measure the distance between my hands, can you bend that distance and make it shorter and longer?
Yes, I can, but it depends
Lord.
on.
So wait, you're telling me
you keep asking the question, but then you keep interrupting the answer I'm trying to give you.
Well, because it's just so ridiculous.
Well, no, how can you know that it's ridiculous when you haven't even heard the full answer because you keep interrupting me every time I try to give it?
Because if you're going to tell me there's 6 inches of space and you can change that 6 inches to 4 inches, you're saying 6 inches equals 4 inches. That's ridiculous.
Well, that's not what
We're not even based in logic right now.
I am sharing my screen because it shows a useful animation of what gravity is in terms of what
gravity
it does
is a useful animation.
Yes. So if you can see this animation, that object would be a massive body like the Earth, and the coordinate plane that you see would represent the curvature, the warping of the geometry of that plane we feel as gravity. Any object present in that curvature, like if you put a bowling ball on a trampoline and then set a marble on that trampoline, the marble will roll toward the bowling ball. It does so because the geometry of the trampoline is curved inward toward the bowling ball. Well, gravity curves the geometry of space-time inward toward that massive body, so that any other body's what's gravity is not strong enough to overcome that field will fall toward that. It doesn't even have to be that strong. The sun is consistently affected by all of the planets that orbit it. The sun consistently wobbles and precesses in its position due to the gravitational pull from all of the planets that orbit it. This animation you're seeing here, this is what gravity is. This is what massive objects do to space-time.
I agree.
This is why gases are held to the surface of the object, because the space-time in which those gases exist is curved inward toward that object, forcing the gases onto its surface. This force is also the reason that objects are spherical, because it pushes inward with equal force on every infinitesimal point on the surface, but the resistive force pushing back outward gives rise to a state called hydrostasis or hydrostatic equilibrium, and that is best served in a spherical form due to conservation laws like energy and momentum.
Except for Earth, which is oblate. But your description of gravity just then destroys itself, because you said with the bowling ball and a marble on a trampoline, that would describe the moon being attracted to the Earth and smashing into the Earth and being stuck to the Earth permanently, not continuously
no.
For thousands and thousands of years as we hurtle through this.
Wait, can I ask you a question?
It's in an orbit. It's falling around the Earth. It's in an orbit.
The moon itself just debunks your whole argument, because if we're moving in one direction,
one second.
Just hurtling through space on the trampoline while the marble goes around it, because that marble would then also have to be accelerating upwards with the bowling ball, which is what you're saying the moon is doing. As the Earth travels multiple different directions, the moon therefore must be accelerating and decelerating the entire time that it is chasing us as we're chasing the sun, which that is impossible.
Can I respond to that really quickly?
Because we haven't heard from Paul for a while, I do want to get to hear from Paul before we go into the Q&A.
Well, I'm no expert on this, but my explanation for that would be the moon is a satellite. It is orbiting the Earth. It is falling around the Earth. Because of the speed that it's traveling at, it never hits the Earth. It keeps missing, so it keeps going round the Earth. That's what's going on. And what Leophilius just showed us there with that demonstration, I've never seen anything like that before, and that perfectly explains what is going on. And if you couldn't see what that model was telling you, then I'd give up. This is absolutely crazy.
Yeah, but look, if the moon misses us just that one time, it's going to keep on going in a straight line. There's no reason.
It's not, because the gravitational pull of the Earth is going to pull it back around.
To respond to what Ross said, I can make it like 15 seconds.
We do want to jump into the Q&A, guys. I just because we do have a lot of questions already, so I do want to get through these. I promise you'll get a chance to potentially, we have so many questions, this topic may come up again. So in which you'd be able to get to jump in, because I know that also Right the Hand, am I pronouncing it right, also had his hand up, and so sorry to jump into it, but I want to say thank you for your questions, folks. Our guests are linked in the description. That's no matter whether you're listening via YouTube, Twitch, or the Modern Day Debate podcast. And by the way, if you haven't found us yet, pull out your phone, find your favorite podcast app, and find Modern Day Debate, as we have been excited that people apparently found it useful. So Sigma Any, thanks so much for your super chat. Says, Predict James will be on time. Ha, very funny. Bumpy Earth 420 says Globe's getting wrecked tonight, especially when the moderation isn't biased. The horizon is not the curve.
I don't know what that
Globies,
means.
are you going to take that?
I don't know what that means. I don't know what they're trying to say. It
Not
means
entirely sure what the point was.
Yeah, I think that is to do with the horizon, is to do with your perspective. So the apparent horizon isn't the same as the geological horizon due to atmospheric refraction. So you never actually see the curve. You see the apparent curve.
Gotcha. And Cider
Here in
Report,
reality, what we see is
Cider
what we
Report,
get.
thanks. I hate to do this, but just because we have so many.
On
Cider
atmosphere.
Report says, how does the flat Earth side explain time zones? It's 1:20 in the morning here as I write this. So how do time zones work on a flat Earth surface?
I already explained that earlier by saying that the sun is the hour hand of a 24-hour clock. And so wherever it is locally, that's our local midday. Where it is 90 degrees to that one side would be 6 a.m. on one side and 6 p.m. on the other. And as it goes, and the direct opposite side of it would be 12 midnight. So as it moves around, that creates the time zones, which more or less match geographically. They are done to match nations and for political reasons and so on. Like China only has one time zone, but time zones are easily explained by the flat Earth surface basically being the face of a 24-hour clock.
Gotcha. King024, I hate to do this, but we have so many questions. It says,
It's all good. Go
question for the flat Earth people. Please make a novel prediction using your understanding of the flat Earth model that can be used in real world scenarios to figure something or anything out.
Timeanddate.com is a flat Earth map, square, flat. It'll give you sunrise, sunset for the next 30 years. It's flat. There you go.
Juicy Sigma Any, thank you for your question. Said, Ross, did you get a chance to Google theodolite? Since our pre-debate debate, some research into professional measurement tools is in order before claiming to understand more about measurement than a geospatial engineer.
I'd already explained how the theodolite works to him. It's simply a basic way of overcoming the limits of our human vision when we're looking into the far distance. When we look into the far distance, everything converges at eye level, which is what horizontal is all about. It's the video I uploaded due to that discussion before this debate started on my channel shows perfectly how it works. The theodolite simply shows how your elevation would actually appear at that far distance where the convergence point is, because we know we're higher than the water level beneath us. It just appears to come to eye level. The theodolite overcomes that visual limitation and shows you what your actual level would appear to be.
Everything
Gotcha.
he said was wrong, completely
I hate to
wrong.
do this, but I have to jump to the next one because we have so many questions. Cider and Port says Ross sounds like an Aussie, even if or Aussie. That's right. Even if he isn't, my question is: Australia has their summer during the winter months. How is this possible on a flat Earth?
Okay, well, I've also tried to explain that briefly in my introduction, and that's simply because the sun moves in a spiral around us, around the equator, and it moves upwards until June 22nd. That's the highest point. And so when it's furthest away from us, it appears to make a much smaller circle. So when it's further from us, then it's direct light coming through the angle of our atmosphere after the firmament means that the light is diluted a lot more, so we get less heat. So that's why we're having winter, while the inner side has the direct light straight through to it, so it has summer. And as it spirals back down again, it appears to make a much bigger circle, which goes out to the Tropic of Capricorn. And then the light is coming through less atmosphere directly to us, so it gives us summer. And you'll notice that in the southern side, we have much longer and hotter summers than the inner side do. They have a much shorter, moderate one.
Next up,
But the sun changes
King024.
speed then.
King024, thank you for your question. Said watching a quote unquote adult man pouring water over a little ball and shaking his head is quite possibly one of the saddest things I have witnessed. I can't remember who did that. Did anybody do that? I don't remember seeing that.
That was right the hand, but I want to say, to be fair, I believe it was a fruit and not a ball. So let's get our criticism correct. It was a fruit.
Right the hand. So sorry, buddy. Teasing is a love language, King024. Oh, Sigma Any says, Bev, are you the same Bev, in parentheses, on the level Bev, that attempted to challenge land surveyors on Reddit about how to make common measurements such as level?
I asked them about my test. Well, it's a straight line proof test using water levels. In reality, using practical geometry, yeah. And the trolls hit us really hard.
What you have on your board is incorrect, by the way.
This one from Kang024 says, oh, got that. Chris Gammon, good to see you, says, flat earthers. Fast jet with unlimited fuel flying straight at the sun will take you around the globe to where you began. The plane didn't turn. Explain that.
The plane did turn, because if it's following the sun is going around the equator the whole time. Even though you might see it through a different angle of the, you might see it through a different angle through the firmament, but you're still going westwards in a great circle. So you might think you're not turning, but if you're following the sun or you're following a compass, you are making a very slow, gradual turn, which will bring you back to where you started.
Gotcha. This one coming in from Kang024 says, the sun does not change angular size to an observer as it sets, so it's not moving away. Question for the flat earth people, please explain a sunset.
Well, that's quite easy as well, because we are seeing the sun as a hotspot apparition through the firmament. Now, as I described the firmament as like a big sheet of ice above us, once it hits that sheet of ice, it's still going to create the same size apparition, regardless of how far away you are from it. It's just that as it gets further away, it's going to get lower and lower until convergence obscures it from your point of view, and then the light itself will no longer reach us, and so it goes dark, and that's what we call sunset. We have long drawn-out twilights as well, which you cannot possibly have on a globe Earth, because if the globe was spinning, as they say, at over 1,000 miles per hour, going the opposite direction away from the sun, the shadow of the Earth would instantly render you into darkness, and you would not have a long drawn-out twilight. You'd be instantly in the shadow.
Question for Bev. They're coming after you, Bev. This is from Kang024, who says, are you familiar with non-rational B-splines? They are geometrical primitives used for making lots and lots of real-world things.
Yeah, I'm just, all I do is the real basic stuff, just talking about basic horizontal and water levels.
Gotcha. And Mark Reed says, Ross, you are Australian. Why can you not see the star Polaris from Australia? Why can't anyone in the UK or North America see the Southern Cross?
As I already explained, distance makes things disappear. As you get further away from things, they appear to get lower and lower. The stars are not immune to that natural law of perspective. It's the same as if you move away from a mountain, that mountain will appear to get lower and lower until eventually it's obscured by the convergence point. The stars do the same thing. And basically the equator is the cutoff point from where you...
What is that distance?
Well, the equator is the distance where Polaris disappears from view. What is that, 4,000 miles from the North Pole? Yeah.
That's not a large distance.
It's about 5,500, because it's not the radius of the Earth, is it? It's greater. So,
okay, so what you have is a post hoc justification that doesn't match observations. Okay, that's fine. Anyway, continue. I'm sorry to interrupt.
Next one coming in from B-Ball for Life says, Bev, why do surveyors' manuals say geodetic surveys of large areas are affected by and must take into account the curvature of the Earth, location on the Earth, surface, and elevation above sea level?
The elevation is measured from a horizontal base, from the datum on a vertical datum. And I think what he's talking about, they say over 100 square miles, I think. Any project over 100 square miles is where they take into geodetic. Anything under that would be classed as planar surveying, as are all the tools are planar surveyor tools.
No, they take it into account when making bridges. Don't have to be over 100 miles.
This one comes in
Correct.
from Decepticons Forever, who says, how do tides work on a flat Earth? Right the hand.
Oh yeah, that's an easy one. So my flat Earth is the Pac-Man, right? Probably heard of it. Pac-Man Earth. Things just go from one side to the other. I'm working on the portal, whatever. Why? So picture a wave. If you had a wave that just went across, the down part of the wave is your low tide, and then as the wave comes up, that's your high tide. So if you had a wave slowly moving across the flat Earth or the flat plane Earth, you would have high tide where the crest is and low tide where the valley
What
is.
causes the waves?
Bro, you're asking me like what causes the sun? I don't know.
I can tell you what
I
causes
think
the
that's
sun,
better.
actually. Gravity and gaseous clouds. But what
Yeah, okay,
causes
great.
those waves?
Gravity and gas.
Where did those waves come from? Did they just magically appear, or did something create them? And if so,
Well,
what?
maybe the wave has something to do with the sun moving over the.
I have
How would the
We've
sun
got
cause
Ross.
the
Ross
waves?
wants to
Bro,
add some
how
as
does
well.
how does space-time bending change
Ross wants
the
to add some as
between
well.
my
How do you
hands?
get high
I don't
tide at
know.
night?
Sometimes
Explain
things,
that.
you know,
Let's
I
hear
already
from-
explained that.
Let's hear from Ross.
I have a very real explanation for why the tides exist on the planar Earth, and they are linked exactly to the moon. The moon is held aloft
Correct.
above it by a weak diamagnetic force, which as
Gravity.
it revolves around us, it's a repelling force. You cannot pull water, but you can push water. Try using a straw
You can
above a
pull
glass of
water.
water and try to suck water in with the straw above the water, but then try blowing on it, you can easily repel water. So what the moon is doing by this weak force is actually pushing the oceans around in front of it. Now, as it goes around on a circuit, of course, it hits the coastline of a continent and the water can go no further. That's the high tide, and then the water starts receding and going back. Water has a backwash effect. It's part of dynamics, fluid dynamics. And so as the water goes back again, it creates a secondary high tide back on the opposite shore from which it came, by which time the moon has made a full circle 24 hours, 50 minutes later, and starts repelling it forward again to create the next high tide back the other way again. So that's why we can get 2 high tides and 2 low tides every single day on the stationary planar Earth, but you cannot have 2 high tides and 2 low tides on the globe with one moon pulling the oceans in one direction. You get one massive high tide and one massive low tide
Paul,
every 24 hours, 50 minutes. But
any
this
thoughts,
matches
Paul?
the moon cycles 100%.
We haven't heard from you for a while, Paul. Go.
No, I haven't got any thoughts.
Dapper?
This is the maddest thing I've ever taken part in.
Dapper, are you still there?
I am sorry. Yeah, I was muted because there was a dog barking. So I will give Ross this. He at least actually answered the question, but again demonstrated a complete lack of understanding of the standard model which he's seeking to criticize, which in fact does account for the just over twice daily tide cycle, because the tide cycle doesn't take quite 24 hours. So yeah, it's just another example of the flat Earth side just failing to actually understand. Oh, sorry, yeah, you're right. So it's just another example of the flat Earth side failing to actually understand the model they claim to be criticizing. So it's very frustrating.
You have no explanation for the secondary high
We
tide.
should jump into the next one.
Claim that the Earth is pulled through the
I hate
ocean
to
for the
do
second
this.
one.
Gentlemen, we
Ridiculous.
should jump into the next one. But
Can I
John,
give a response? They can make it quick, really quick.
I hate
Very
to say
quick.
no, but we have a lot of questions. Do
Go
want to
ahead,
say
go
we appreciate your question, especially it is for you, Leo. Cider and Port says, for Leo, in your opinion, why is there a correlation between someone's opinion on the flatness of the Earth and this? Okay, gosh, looking for more serious questions. Leo, will give you a chance to respond since this wasn't a serious question. What did you want to say?
So the reason that tides exist is because of the gravitational force that the moon exerts on the Earth. So I believe Ross is the name. He is right when he says that it is the moon, and it is a result of the moon orbits the Earth slightly faster than the Earth rotates. And as the moon comes around the Earth, the ocean tides, and obviously I'm exaggerating, will move upward toward it due to the gravitational pull, and that results in what we call tides. And this is why other gravitational forces that can even actually physically stretch and move moons or other planets, like we see with some moons of Jupiter, this is why we call them tidal forces or tidal effects, because they result from gravity.
You've got 2 moons in the one day, 2 tides, but there's only 1 moon. Where's the second high tide come from?
It's emergent from the fact that when water is pulled in one direction, it has to come from the sides, and that lateral motion is differential to the opposite side of the bulge, which means that relative to the low tide, there is a less high but still high tide opposite the moon, which the high tide itself is offset due to the rotation of both the moon and the earth.
No, that would be the low tide.
I know that's what you think, but that's not what the model is.
We must go to the next one. John W. says, I love this channel. Respect to you, friends. Even if I do not agree, I love hearing ideas and knowledge. John W., thanks for your support. And you can find all of our guests' links in the description. And Titanicus Andronicus, thanks for your question. Said, if equations are wizardry, then algebra is black magic. Great show. Thanks for that. And John W. says, globe Earth, but I may be ignorant. It just makes more sense. Love the debate. Thanks so much. Appreciate it, John W., for your support. The Crawdaddy says, I like flat earthers. Let's see.
Okay.
Hey, James. James, do you mind if I quickly address that first comment you made about the black magic sort of thing?
Go ahead.
Because it's quite ironic is that the globe depends 100% entirely upon this black magic, which they call the dark force or dark energy, dark matter. But it's 70% stronger than gravity itself. So first they invent gravity to make the world possible, but then to make the universe possible, to stop it all colliding into a singularity, they use this dark force or dark matter, which has never been seen, but they can tell that it exists because of their wizardry formulas.
Next up, B-Ball for Life says the stars are 70 miles away. Wow. So the stars are closer to me than California, and I'm Hawaii. I think they're saying I'm in Hawaii. I don't know, but they say, are the stars closer to B-Ball for Life than California is?
What I was saying is the apparition of the stars are 70 miles away. The true star might be any given distance above that we would never know, because the firmament is the place where we get the first reaction of the electrostimulation of these various things that create the energies that create light in the firmament. Then with the sun, of course, being the greatest of them all, and the stars, but they all appear in the firmament, which is why the ancients have always said that the stars and the sun are in the firmament, because that's, to all intents and purposes, where they appear to us, in it, whereas they could be any massive distance above it.
John W. says, I am more interested in the awesome work of the middle guy on the whiteboard. Well, so it's been interesting to see the different gadgets and things on screen there. Mr. Wilford says, for the flat earthers, explain in particular, Right the Hand and Bev, why standard candles don't allow us to say stars are millions/billions of light years away.
So is this guy's argument because there's candles that a star is 1 billion miles away?
Wait, you don't know what the term standard candle means even? Oh, wow.
Candlelight luminosity. Okay, so things have
really harsh.
Bro, because I didn't hear what he said, bro. Chill out. So because something has a candle watt power and we call the brightness candle watt, that means something can be 1 trillion miles away.
No, that's not what that is.
No. All right, yeah. Okay.
Let's hear briefly, Dapper, if you're willing to share what a standard candle is, and then we can give a chance from Right the Hand.
So a standard candle is an object of a known absolute luminosity. So we know exactly how bright it is from a given distance. And then when we see that particular object, we can measure its apparent luminosity and then use the inverse square law to calculate its distance. Because if you have its apparent luminosity in the inverse square law, you only have one unknown variable, and that's distance. You just rearrange it with algebra, you get the distance.
Yeah, so have you ever gotten right next to the sun and then walked 10 feet away from it and know what the brightness
nothing to do with what he
hold on. Let me just say, or are you saying because a candle behaves like this, the sun, which doesn't sit
Why are you stuck on candles?
Hold on, bro. The sun, which doesn't sit on a desk burning wick, should behave like the candle. That's ridiculous. When you project the candle or any type of candle light, floating in the sky above me, then I'll believe that stars are millions of miles away, man.
You're a Poe.
I'll tell you what,
have to be a Poe.
Right the Hand. When you figure out a way for the sun to work differently that doesn't involve special pleading, let me know.
You're saying figure this every day we wake up and see a sunrise and a sunset, and you're going, how does that work? Bro,
No,
you
I know
don't
how it
see
works.
how things work. You just see that
Yes,
they
I
work.
do.
So when you hold on, so
No.
when you ask me how does the sun work, you're somehow thinking that you conceive why something happens and the thing that happens. No, you see the sunrise and the sunset. That's it. Now, if you want to believe that's because the ground you stand on is spinning, that's
Yeah.
fine.
I'm going to cut in.
But that
I
is
hate
what,
to do
yes.
this, but Sigma Any, thanks for your question. Said human beings are intriguingly diverse critters. Thanks for that. Kango24 says for Bev, do you understand the difference between objects that are small and objects that are far away?
You have some Father Ted here.
Difference between them. Yeah, of course.
Bev.
For all intents and purposes, it's the same thing, isn't it?
Did he give you a lot of money for that?
I'm sorry, I need to mute myself.
The large thing will look very small further away, whereas a small thing will look quite large up close. But it's all perspective, isn't it?
Wait, hold on. Just really quickly. Can I ask you
Well,
a
Small
question?
thing will be
talk,
even smaller when it's further away. won't it?
just- I mean, this could be really quick.
Questions.
This is
Like
really
10
quick.
seconds, Leo.
Yes, Ross. So does that mean that a sphere can look flat, really close, but far away it can look spherical? Because that would follow from what you just said.
Depends on that, but you'd still see curvature because any sphere, by definition, has.
So you're
sphericity.
conceding. All right, you can
All
continue,
that.
James.
A
You know,
sphere
if
is
you-
the
same
surface of
rules.
constant
If you ask him a
curvature.
question, you got to let him
Phyllis, yes.
respond. I don't know if he's done. Go ahead, Ross.
I was just saying, a sphere, by definition, has sphericity or curvature in all directions. It doesn't just exist in the far distance where it's out of sight, out of mind. You must be seeing it left to right as well for it to be spherical.
Yeah, he's
And
conceding.
here's what you will
point.
see on the sphere. You
Jeez,
will see that
Leo,
on any
you're a
board.
little bit impulsive, buddy. I hate to call you out for that, but jeez. All right. John W., thanks for your question. Says, I am driven to drink because this is my life the way it is, but flat earth versus globe. Thank you for that. T Fish says, saying anything is over 1 trillion miles away is a maniacal fantasy. I don't understand how this is even a debate anymore.
I'm sorry, the big numbers confuse you.
Yep.
That's all I got.
Decepticons
The
Forever
big
says,
numbers are confusing. We don't
Decepticons,
understand big numbers.
we must jump to the next one. Decepticons Forever says, Emil from RoboCop doesn't understand distance. Sad. Who's Emil from RoboCop? Next up, Chris says, question for Globers. Which unis did you guys learn this mysterious math wizardry I've heard so much about? Hogwarts?
The University of Massachusetts in Lowell.
Gotcha. And 2 seconds. Want to remind you folks, our guests are linked in the description. We've got more questions. Right now, the page is just loading. Very embarrassing. But thank you guys so much for your questions. This next one coming in from EndoXD, who says, do you not know Einstein's theory of general relativity? Gravity is the curvature of space-time. Saying that's ridiculous is an argument from incredulity.
It's an argument from actual observation of reality.
No,
We
it's
don't
not.
see anything called space and time curving whatsoever.
Yes, we do.
Just demonstrated.
Except when we watch gravitational
We did.
lensing happen, which we see all the time.
The
So,
observations that Einstein and Sir Arthur Eddington made in 1917 that confirmed general relativity were observing stars further out from the sun than what they should be because their light was being curved by the sun's gravity. This is how general relativity was confirmed. Yes, we have literally observed the lensing of light due to the result of gravitational fields. We utilize this every day in calculations. This is well accepted amongst all astrophysicists and cosmologists. Anybody denying it straightforwardly just does not understand the mathematics.
Or does not follow your
observe as it
religion.
should be, right? Like it's like, oh, it should look like this, but it doesn't. Bro, how do you know what something should look like? The only way it looks like it looks. If you think it should look like something else, that's irrelevant to how it looks, bro. So your whole argument was it should look like this. It doesn't. It looks like it does. Therefore, we're right. Yeah,
So you don't know how predictions work in science. That's fine.
This next one coming in from, do appreciate your question. This one is from the Crawdaddy029. Says, how does the flat earth explain how distances on the globe earth work out correctly to scale, but the flat earth map does not?
I'll take that one. All of the measured distances are either measured of vertical for elevation or horizontal for distance in between points. They're the only two frames of reference that we have, horizontal and vertical.
Next up,
Navigation on the flat Earth model would be almost impossible.
Next up,
Well,
Matthew.
you can't measure distance across water, though, can you? That's the
Yes,
problem.
you can.
Gosh, it can measure
You can't.
distance
You
across
can,
water.
you can estimate
you
it
can.
by average
Anyways,
speed.
continue.
Jeez, we're talking about actual measurements, and you just anyway. Let's
No, you're
continue.
not.
No.
Yeah, I
Anyway.
was in the
Let's
Navy.
talk
You can
about
definitely
actual
measure your
distance.
distance across
You
water.
can't use an odometer in the water because you've got water currents, you've got all sorts of different things that can affect it. You can work out average speed and estimate how far you've gone, or knots of miles, which is a rate of knots of a rope leaving the boat.
Nautical miles?
Knots, because
Nautical
it's knots
miles?
for a rope, and that will tell you speed by how fast the rope comes out the back of the boat before you have to wind it back in and start again. Yeah, nautical miles are done by latitude as opposed to real miles, which are done over land.
Oh my God.
Based on a globe.
Let's hear from Paul.
Come to the globe Earth.
Based on using circular geometry around the center point to use for navigation. You've used latitude lines in ever-increasing circles around the middle point, which naturally then a nautical mile gets bigger and bigger the further outwards you go.
Let's
That's
give
true.
because we
That's true.
haven't heard a ton from Paul. Paul, what were your thoughts on that? And then we're going to jump to the next question.
I have no idea what he was talking about on the last bit. But yes, you can measure distance over water. Of course you can.
Next up, Matthew Steele says, why has no flat earther ever taken just a single video from the edge of the earth?
That's a ridiculous question because there is no edge of the earth. We believe it's infinite. It goes forever, but the limits of where we can reach is Antarctica, and there are thousands of videos of Antarctica showing a massive ice wall surrounding us.
Juicy. Mark Reed, thank you for your question, says, so if we set up a vacuum chamber, Ross, and drop objects, they still drop to the floor at the same speed. Why would that happen?
Because the vacuum is the absolute lack of resistance. Whereas, if you dropped a feather in air, a feather has some amount of air resistance. So that's why it gets resisted on its way down. Whereas if you drop
why does it fall down and not
but
go
why
up?
do they fall down at the same speed?
Exactly. Why does it go down and not up?
They both lack resistance from the medium they're in.
Yeah, but why do they fall down at the same speed?
Well, they stop when they hit the floor.
Without the resistance, what's dictating they fall down at the same speed? Could it be Newton's universal gravitational constant?
You can call it whatever you like, but it's still the lack of resistance, an absolute lack of resistance.
Which is defined by what?
It falls by the fact of having mass in a place that has no mass to resist.
Space-time? Yeah, curvature. Thank you. Yep.
No, in a vacuum. Nothing to do with space-time or any curvature. It just falls straight down.
Yeah, but why does it go down? If it's to do with density and you've taken everything out of the chamber apart from the object, why does the object fall down and not go up? How does it go?
Because the resistance force always comes from beneath. That's universally being known.
How do we determine that? What experiments determine that? What mathematics defines it?
We don't need mathematics. You just need logical observation.
Yes,
look that everything comes to rest when something of sufficient density resists it from falling any further.
How do you define your observations if you're not using mathematics? Do you realize how dependent physics is on math?
Relative density, mate. Like relative density.
Yeah, but how do you mathematically define that?
It's sufficiently, well, you can measure it by how much volume it takes up and how much
the equation?
Weight. You really need to do it mathematically, but the mathematics is irrelevant to the reality of what's actually happening.
Would you put it on a vertical scale?
Wait, you guys are saying mathematics is irrelevant in your physics. I mean, I'm not surprised by that, but if you understand what physics is, you'll know why mathematics is so important.
Mathematical explanation for it. The mathematical explanation is irrelevant to why it does it. The mathematical explanation just explains what happens and the amount it happens, but it doesn't say why it happens is because there's no resistance beneath it to prevent it from happening.
Yeah, so why does it fall down and not up?
It's a vertical change, isn't it?
So why is it
vertically? That's your geometry. That's your mathematics.
Why is it vertical in one direction but not the other? Why is it going one direction but not the other?
Vertical is up and down, isn't it?
Yes, but so why does it go down and not up?
Because it's not a gas and it's not lighter than the
but we pulled all the gas out.
The gas out.
Why does it go down?
I appreciate your guys' gusto. Just that we have more questions. Sleepy Dan says, my glass of ice doesn't get heavier as it melts into a more dense liquid. Relative density is bunk and easily proven wrong.
Well, that's ridiculous as well, because when the ice freezes, it expands. So it takes up more space, which is why it floats in water. But as it melts and becomes back to the liquid state of water, it's still water. It doesn't increase in weight. It's still the exact same amount of water it began with.
Next up, the Crawdaddy 029. This is a two-parter. He says, that's not Ocean's razor, but it's weird. I think they must have meant Occam's. That's not Occam's razor, but it's weird for you to say the simplest answer is the most likely correct. What's more likely? That there is a major world conspiracy, a project manager's nightmare of people keeping the flat earth a secret, or that the world is just a sphere.
Well, that's the sphere is the manufactured thing, which we're all brought up from childhood to believe. So you've got no reason to disbelieve the adults who taught you as you grew up. It's only as you grow up and start to think for yourself that you start to question the dominant paradigm of what we're told is reality. As soon as you realize, hang on a second, it takes many of us many years before we start to question what we're told to believe in. We think we live on a ball. Of course we believe it because all authorities say so. But all of these authorities have been indoctrinated with the same stuff from their childhood as well. They've got no reason to question it. They never did. And if they did, they would become the laughing stock of their school or their college, whatever, and they get laughed out of society. They get treated as a pariah, as flat earthers often do. And so most people just go along to get along. They don't want to rock the boat. They want to keep their cruisy jobs or whatever it is, their happy income. Most politicians, they never considered it one way or the other. They just think, of course it's a globe news. That's what everybody believes. Everybody wants to be popular and, for what, to say the popular thing. You don't want to go against the grain. You just simply want to.
Next.
So this lie's been going for 2,000 years.
It hasn't. It hasn't.
Yes, it has.
Yes, it has.
You've been told it has. It's only been going for like 50 years, really.
Sure.
Like
So 100 years ago, they didn't know that the Earth was a globe. So you're saying 100 years ago, they didn't know the Earth was a globe.
The New York Times in the early 1900s of the flat Earth with the ice wall around.
Do you think that the globe Earth has only existed for the last 50 years?
How tall is the ice wall?
Who cares about how tall it is? It varies.
Well, I mean, if it exists, obviously we've been there by now.
The question is, how long has this been going for? The debate has been raging since the beginning of time, really.
So
and most people
you just said it's been only going on for 50 years.
But since Hollywood took off,
there hasn't been a debate.
Studios start showing this image of the globe, and that same image is the same one that NASA showed us in the 70s or late 60s, whenever they took their first blue marble image. It matches the one that the Universal Studios was showing us since 1927. So they've known about.
Let's be clear about one quick thing, though. There is not a debate. There hasn't been a debate for over 2,000 years.
That's wrong.
What there is fun little entertainment where people who clearly don't actually know the actual science or anything that they would need to criticize anything about science come on and pretend that they know things that are flatly contradicted by obvious observations. That's what we have here. This is theater. This isn't a debate. There hasn't been a debate for over 2,000 years.
Like I said at the beginning,
I'm not actually convinced that you believe it's flat. I'm not convinced you believe it's flat.
We'll give you a really short response, Ross, because I don't want to gang up on you, but then we got to go to the next one.
I'm just saying that nobody was there 2,000 years ago to know whether or not there was a debate raging. We know there was a debate.
People that were there.
All the people writing histories.
All right.
And so we know that people were debating it. You got your Henry Rowbothams and so forth who were doing experiments that proving it's flat. And so this debate was raging. And the only reason it was ever considered settled was because NASA started faking images through a round window of a high altitude vehicle in the late 60s and said, this is a picture of Earth from space. That was when it was settled that we live on a blue ball in space.
Mikey Riot says, James, you got to host Leo again. He's brilliant.
He's good.
That's nice. Your mom's in the chat, Leo. Okay. but seriously, I want to let you know, Leo and all of our guests are linked to the description. So, folks, do encourage you to check them out. We appreciate our guests. We're really glad to have them here. And so, Mr. Wilford, thanks for your question. Says, why do you profit-based airlines will plot their flight paths in fuel inefficient ways, like they're accounting for the curvature of the Earth? Why waste fuel on millions of flights versus just flying in a straight line?
Very good question.
Why do they, why do profit-based airlines fly as if there is curvature in the Earth when they could save a heck of a lot of money by not flying that way?
Exactly.
Just plot it on the flat Earth map, and you'll see they're going in the straightest line possible. They're not matching the globe whatsoever.
Yeah, but the lines are curved.
Yeah, when
That's
you
how
plot
they're
any
going on the-
commercial
When
flight,
you put it on the navigational chart, it's curved.
Yeah, they're curved. They're geodesics.
and I mean,
That's how
this
they come to
this
the
isn't even
screen.
hard to do. You can watch in many current
Straight
planes.
line.
You can watch where you are on a map of the Earth that is usually some kind of like Mercator-like projection, and you can watch your flight path curve. And you can also look out the window and notice that what you see out the window matches what you should be seeing based on your flight path, and it still works over land. Granted, if it were all over water, it would be hard to check, but it all lines up. So really all you need to do to prove the Earth is a globe is take a flight of any great distance over
And watch
land.
the television screen in front of you.
No,
You
watch
look
that,
out the
and
window,
then
you'll
also
see
look
the horizon.
outside, and then double check the map. You can also even have people stationed on the ground if you want to coordinate to spot your actual plane, because there are plane tracking apps. And you can say, hey, look, that's actually the plane.
I think we should let the pilot
Look out
Oh,
the
yeah,
window
sorry.
and notice-
give a comment.
We do
Paul.
have a pilot.
Yeah,
Notice
Paul,
how you
let us know
never
what's
go
up.
upside down.
Yeah, on
when you're flying.
long distance flights, if you plot it on a flat map, you will put a curve into it to account for the curvature of the Earth. On a short distance that I fly, I don't bother with that because I'm only doing 60 miles. If any great distance, you include the curve for exactly what was said in the question, to save on fuel and to save on distance.
Yes.
So if you fly like 2,000 miles, you're going to start here, and then you're going to be directly under yourself.
Yes.
Oh, because the Earth is, well, it's not, Earth is much bigger than 2,000 miles in circumference.
Okay.
So,
So
no,
how many miles do you have to go before you're completely under yourself?
half the circumference.
Yeah.
And you feel that orientation change, right? Of course.
No.
No,
Why
no,
would you feel the
So it's
orientation
almost,
change
would
when
you
you've
say
got
it's
gravity?
almost like you're flying over orientation wise? You never feel that. So it's almost like you're just going
No,
flat.
because it's the same
No,
center
it's how
of
it
gravity.
feels. I'm just saying how it feels. It
Yeah.
feels like you're going flat. Yeah, it feels like
Yeah,
you're going
because the center of
concession.
gravity
That's a
does not
concession. I'll
change.
take it.
Can I just ask?
Because you are horizontal to the globe.
Horizontal, okay.
Yeah,
Now,
you're
one question
always horizontal with the center of gravity.
is the
so you're not
amount
gonna-
of air curvature altitude dependent?
What do you mean?
Is the what?
What do you
The
mean by air
amount of curvature
in the atmosphere?
yeah, is that
Well-
altitude dependent?
Yeah, I mean, the higher up you go, the larger the diameter is going to be.
What about the spin of the Earth beneath you? How do you account for that if it goes twice the speed of the airplane?
Because the atmosphere is traveling with the globe at the same time.
Exactly.
It's all moving at the same time.
Remember your whole thing
Like
about
it's
how
a
you can't
stationary
measure
Earth.
distance because of relative motion of the Earth and the. So Ross,
Pick that
Stationary
up.
Earth is going
Ross-
1,000 miles per hour.
No.
Ross,
The
the problem
atmosphere
you're having
doesn't
here-
turn at 1,000 miles per hour. It turns relative to the
Is it-
speed given your position on the surface of the Earth. Because
Okay,
the
it's
closer
basically-
to the poles you go from the equator, the lower the surface velocity of the rotation of the Earth is. This is why when we talk about the rotation of the Earth, the most accurate measurement is to say that it rotates at a rate of 3 degrees per hour, 15 degrees per hour.
Well, what is wind?
Wind is motion of the air
local
relative to the
motion.
surface.
Yeah, it's
Yeah.
local motion of the wind
Hmm.
relative to the surface
So
of that
the
area.
local
That is
motion
generally
over-
driven by differences in pressure, by
But
pressure gradients and energy from the sun.
Yes, caused by the warm air currents.
Yeah.
But you just said the whole atmosphere is moving with the Earth, and yet
Yeah.
The
Yes.
atmosphere
As a whole,
is
on average,
moving
yes.
in relation to
Wait,
the
hold
Earth,
on,
but
Ross.
inside that, it's fluid.
Ross, have you ever been looking at a river or a creek flowing, and you'll notice that there are places where the river might start to circle or swirl or anything? There's backward motion in that river, but the river is still generally flowing in one direction. Same basic principle. The atmosphere of the Earth is very turbulent. It generally moves with the Earth, but there are points in it and areas in it where it's still rotating with the Earth, but that atmosphere is moving relative to the gradients in the pressure.
The ground beneath the river isn't moving with the river. You know, the
What's
river is
that?
moving independent. The river is moving independent of the ground. The ground isn't moving with the
I
river.
wasn't talking about the ground.
I want to give Leo a chance to respond,
Well,
and then we got to go to the next
Earth
one.
against the ground is moving with the atmosphere. And so you're comparing the atmosphere to a river above a stationary ground and
It
saying
was
that the
using
ground
the river to explain what was going on. It wasn't
Yeah.
comparing the two together. It was using the river
to explain what you
I was
can
using
see.
the concept of a river flowing, and then like if you put a rock
So
in the middle of the
water is
river,
flowing.
it might
Hold on,
cause
Ron.
some swirling to occur, but the river is still moving in the same general direction. It's the same thing with our atmosphere. There's
One sec.
turbulence.
Well, let's let
There's
Leo finish. I
turbulence.
promise we'll come right back to you, Ross.
It's like the ground is stationary.
I'm not talking about the ground is not relevant here.
It is
what
relevant.
I'm not the example I gave.
I
I don't know how often you've floated a river, but I've done it a lot. There's rocks and differences and everything like that that can cause the river, although it's flowing in one direction, there can be points where it swirls or points where it flows backward and then comes back around. That's called turbulence. We have that in Earth's atmosphere, despite the fact that it rotates, because the friction of the surface of the Earth on the atmosphere over the billions of years that the Earth has been rotating will begin to drag on the atmosphere and cause the atmosphere to rotate with it.
You have to bring in the billions of years, don't you, to say that this is why the atmosphere moves with the Earth.
We know that the Earth has existed for billions of years. So I mean,
the water is flowing through the river banks, and so the wind is moving independent of the Earth. It's not moving with the Earth. The Earth is like the river banks. The wind is moving independently. Because if you're saying that the wind is also moving at 1,000 miles per hour with the Earth,
can I just get a quick one in here, Ross, please? Leo, would that make the because the air's curvature, would that mean the curvature of the water level would also be elevation dependent?
I want to let Leo answer, then we have to go to the next question.
What I mean, if you're talking about the relative angle on a sphere, when you move from the center out to the full circumference, the angle of two lines defining those points will increase. So you could say that theta, your angle, will increase. If that's what you mean, then yes.
No,
if
just
not,
the
we have to go
curvature,
further.
the amount
into
of
it.
curvature of the water
We must
level.
go to the next one. I hate to do that, but the Crawdaddy029 says, how does the flat earther side explain that when you go south and get to Antarctica and turn left to follow it, you make all right turns around it? I'm the only person confused.
I would like to know if he's done that. Has he done that traveling trip to confirm that's what happens, or is he just going on his model in his head?
Next up, Magellan says, flat earthers, why does celestial navigation require spherical trigonometry to get a position fix?
It doesn't.
Yes, it does.
Triangulation has to be done through a triangle. If you don't use a triangle, you can't triangulate.
So you don't know what spherical geometry is.
You have
or
that
spherical
azimuthal
trigonometry.
angle.
Leo, that's been pretty clear for a
celestial
while.
navigation.
I mean, it has.
That's not
Next up.
celestial navigation. That's using
Magellan.
tower navigation via GPS. You got two or more towers, you can pinpoint his position because the towers are fixed. While you're moving, it will tell you where you are.
Paul, is this true?
But GPS are on towers. So explain how you can get GPS signal then in the middle of the ocean.
Exactly.
It's radio signals. Radio signals propagate for hundreds, if not thousands of miles.
Man, if only radar horizons weren't a thing, so many lives could have been saved in World War II because it would have been impossible to ambush fleets on the ocean. And yet it still happens.
Somebody was able to talk to Hawaii with a normal ham radio, even though he had illegal crystals in it, which gave him channels that you're not supposed to have here in Australia. He was able to
that'd be the radios that you bounce off the atmosphere to go across the curve.
Yeah.
I used to do that myself.
Must
It's funny how you can't always do that because it's dependent on atmospheric conditions.
Exactly, it's dependent on what the atmosphere
You
is
can't
doing at
bounce
the
off
time.
a vacuum.
You get the
but you can bounce off
ionosphere,
the vacuum.
which you can bounce the radio signal off it, so you can go a further
But an
distance. I used to do it 20 years ago.
ionosphere is decreasing density of anything. There's more nothingness than anything.
No,
That's how your gravity works in the first place. The stronger the gravity pull is, then the more dense the air gets lower down, hence we have the air pressure gradient according to gravity, which we just call it the volume of it and the amount of it pressing down on you. But if you're getting up to the ionosphere, you're talking about nothing. But if it was an actual firmament, you could actually bounce something off it like radio waves.
You do bounce stuff off the ionosphere. That's exactly
So
what
Ross
you do with
doesn't
radio
know how
waves.
electromagnetic radiation
Cleary
works.
says, thanks for your question. Can Bev explain how right line geometry defines the Euclidean 3 space of our world?
Yeah, easily. Thanks, Cleary. Yeah, the right lines are the two right lines that make a right angle. They are a horizontal, plane, and a vertical. those two reference frames are the reference frames that we use in reality all the time. We use a tool called a level to establish a horizontal, and then we measure vertical change. That vertical change from that horizontal is elevation change. I mean, that's how it works in reality.
Gotcha. Next up, this one
Is that horizontal?
I can't see.
I can't. Oh, there it is.
Now we can.
What?
The line on the
Line.
top of the circle I've done, is that horizontal?
Put a level on it. Yeah.
Yeah. Is that horizontal?
Nah. That looks
It is if you're on the globe.
It's not.
Yeah. It is if the center of gravity is the center
The
of the
Exactly.
the
Earth.
horizontals don't turn into verticals. They just don't.
You're
It's
right, they don't.
horizontal to the globe.
We must jump into
Oh,
the
man.
next one. Matthew Steele says, Leo, are you familiar with cat Earth theory? If the Earth were flat, cats would push everything off of it.
Yeah.
That's funny. Yes,
Yeah.
I am familiar with that.
By the
Funny
way,
that cats don't like water, so they're not going to swim all the way to Antarctica, and it's a little
I
bit
don't
too
know about that.
cold. Cats would become icicles in no time at all.
anyway, I was going to also say, Leo, I'm sincerely sorry I was so rude to you earlier.
Right, I won't carry on. It looks like there's about another. How long is there left on Q&A? There's about another 40 minutes left on the Q&A, so I'll stop it there. Oh, what was that like? To be honest, it's probably one of the best ones I've been involved in. It really was. But I hope I don't get invited on any more. It was absolutely painful. A bit earlier on, I did put in the chat the link if anyone wants to jump in just for like 5-10 minutes, because I need to start getting ready, because I've been called out for gritting again tonight. So I've got about another 2.5 hours before the grit, but I need to get there before obviously get loaded up. I'll just do it again just in case it's disappeared. I'll just copy the link in. Right, I've just put the link in the chat. So if anyone wants to jump in for 5 minutes and have a chat and see what you think, junk shot, I've got to give you how the hell you sat through the whole of that lot, and if anybody else has managed to stay from the start to the well, it's not even the end. Let's say there's about another 40 minutes of Q&A left. I think the whole thing was on for about 3 hours, nearly 3 hours. Right, so I just can't wait for tonight's debate. What's tonight's debate? It isn't me. If you were on about what I put in earlier, that was earlier on. What happened? What is it tonight? I think there is one on tonight, but it's not me. That's the last one I was on. James contacted me last Wednesday and asked me if I'd do a debate, which was on Friday, and this is me just putting that stream out from Friday. I'm supposed to be doing a debate with Gavin on the 25th on is Jesus a myth, or was Jesus a myth? So I've got to prepare for that, but I think that's going to be on. Oh man, I can't remember the bloke's name. When I find out, I'll let people know. But yeah, I've forgotten whose channel that's on. But I think that's the 25th of this month. So yeah, I have no more flat Earth ones to do. I did have one guy. He said he wanted to debate me on the flat Earth, but I might just give that a miss. Yeah, oh Jesus, not Gavin. Yeah, it's Gavin. Right. Does anybody want to jump in? Junk shop, do you want to jump in for 5? I'll give you a minute or two to make your mind up if you want to just jump in. Let's say it'll only be for a minute, just to let me know what you thought of the debate. I had it fairly easy, because as soon as Dapper Dino and Leophilius started, I mean, they were way more educated than I was. So I just sat there and just enjoyed the ride. It was quite funny. So yeah, it was an easy one for me, especially with 3 of us being on the panel. But yeah, don't know. Does anyone want to jump in yet? No. If nobody does turn up, I'll probably end it here. As soon as I get the unfortunately my hands are busy. All right. Oh, okay, Tobin. Yeah. Yeah, I think that's all I've got. Yeah, as soon as James sends me the link for the full thing, I'm going to put that on my my channel so anybody can find it if they want. I did have. Oh, what about now? Yeah, I've got 109 subscribers now, and I gained about 7 or 8 from being on that debate, which I'm really surprised because, like I say, I didn't actually do a great deal of it. But yeah, I gained about another 7 or 8 subscribers, so I'm well over my 100 now, which I'm pleased about. So I'm gonna have to start putting some more stuff out, so at least people can see me me doing something rather than taking part on other people's channels. Fighting a bad anxiety day. All right, okay, fair enough. No worries. Anyway, I'll end it here. Thanks for everybody for turning up. I hope you enjoyed it. It was fun on my side, but yeah, painful to watch. Junk Shop. How the hell do you manage to sit through all of that lot? I had to stop it myself. I thought I can't do another 40 minutes of Q&A. I can't remember what else there was. There was nothing of any great importance, I didn't think. And if you're really that interested, go to Modern Day Debates and watch the last 40 minutes of it. Right, I'm going to knock it on the head here. I don't know if I've got me thing. Yeah, let's put me me thing on. Open that. Right, so I'm going to end it with my little flying video, and then I'll call it a day. I'll catch you all later. Thanks for turning up, everybody. See you later, Junk Shop. See you later, Tobin. Willzone 908. I don't think I've spoke to you before, but thanks for turning up. Who else was there? There was quite a few earlier on. Oh, Brainbug turned up, but I realised, yeah, he had to go off somewhere. I don't know if he's got a live stream going. Oh, Matt Caesar was there as well. Right, lovely. Anyway, I'll put my little flying video on and I'm going to jump out and I'll catch you all later. Have a good night.